ready to go. Do you want me to introduce you?
Oh, no, it's okay.
Okay.
Good morning. Can you guys hear me with the mic? No? No, can't hear?
Well, this is on.
Okay, maybe I should just walk over here.
Can you guys hear us better when we use this, or
Okay.
can you
Okay.
hear us when we're like this?
Okay.
All right, you're going to have to do double mic.
Okay, that's fine. I can stand here too,
Okay.
as long as you guys can see me.
Yep.
Is this okay?
Yeah, how's this, Jim?
Is this all right?
So for some of you, we're also trying to do webinar.
Right.
So we've got you as an audience and the webinar audience trying to keep happy.
So, good morning, everybody. How are you? Welcome to Beach 101. This is our 10th year that we've done Beach 101. We started, wow, this is great. So thank you so much for coming. I'm going to start by just giving a brief overview of how the beach program has come over the last 2 decades. And I'm going to talk about EPA's beach program, the Beach Act, and the Great Lakes Restoration Initiative, and some of the great projects that have been funded in that program. I'm just going to give a few examples. Like I said, I'm just giving a really big picture view of beaches. Shannon's going to give the meat of the project, of the whole program. So get you ready to get your programs up and running. So. Maybe I will take your assistance. All right, how do we get to the next slide? Excuse us. It's like Fox last night.
Hey, Jim, which one do we get to go? Click off. Okay.
You just got to put just PowerPoint in focus.
Oh. Perfect. Do you want me to just give it a shot? Oh, there we go. Okay, perfect. All right, thank you. Hard enough. So anyway, in the Great Lakes, there are about 1,400 beaches along the coast. And these beaches can be affected by a variety of pollution sources. We have human sources of pollution, sewage. We've got combined sewer overflows, your failing septic systems, extreme failings of septic systems. You've got bathing, folks swimming in the water. Shannon, I know you contributing to fecal matter. We've got boats and babies in diapers. And we also have animal sources of pollution. You've got pets, you've got wildlife, waterfowl, which are significant contributors of fecal matter, and confined or concentrated animal feeding operations or livestock. And when it rains, stormwater can wash these species into beach water. Swimmers who are exposed to these species run the risk of being exposed to pathogens that might be present in the fecal matter. And these are the disease-causing microorganisms that are most commonly associated with waterborne illnesses. There are categories into 3 categories: bacteria, viruses, and protozoa. And this is just a partial list of some of the pathogens from EPA's beach guidance documents. And as you can see, most of the diseases relate to gastrointestinal illness, but swimmers can also experience skin rashes, ear, eye, nose, and throat infections, or respiratory illnesses. People do get sick at the beach. I was at a presentation last week by Dr. Sam Dorovich from the University of Illinois at Chicago, and he gave a presentation called A Day at the Beach, A Night at the ER, and he talked about several recreational waterborne illnesses that have happened over the years. And here are just 2 examples that occurred in the Midwest in the mid-90s. In Lake Springfield, Illinois, there was a triathlon, and 98 swimmers, or 12% of the competitors, contracted leptospirosis. And they think it's because of heavy rains that occurred the night before the triathlon. And the reason they found out about this is because there was a triathlon the following weekend in Green Bay, and a lot of the other racers wondered where everybody was, so they called each other and they figured it out, and that's how they pinpointed the lake as a contamination source. And then also in 1995 in Rockford, Illinois, there was a swimming beach where 12 swimmers, children, contracted E. coli 0157H7, which we normally associate with contaminated beef. But they interviewed the parents of the children, and they found out that there was no common food source, and they figured that the kids contracted the illness from swimming. So they did an environmental investigation, and they didn't find any leaking bathroom facilities. They didn't see any animal sources around, any animal feeding operations nearby, no sewage outlets contributing to the lake, and they figured it was a swimmer who was sick and contracted the illness and exposed the other swimmers to the disease. So that's why it's really important that people who are sick stay out of the water, right? So the CDC, they have posters you can download, brochures, you can post at your bathrooms that encourage swimmers to stay out of the lake. Keep your pee, poop, sweat, and dirt out of the lake. And these are great to just post in your bathroom facilities. It's also important to have adequate restroom facilities with hand washing facilities, changing tables for diapers, and keep people out of the water if you're sick, right? So to address protection of public health at beaches, EPA created the beach program in 1997. And the goal was to significantly reduce the risk of waterborne illness to nation's recreational waters through improvements in beach water quality programs, communication of the information to the public, and scientific advances. And these are the key objectives of the beach program. The strengthen water quality standards for beach programs, to improve state and tribal government beach programs, and to provide better information regarding beach water quality to the public, and to promote scientific research to better protect the health of beachgoers. So you'll see these themes are consistent with. So thankfully in 2000, October 2000, the Beach Act was passed, which had the same goals as the beach program to protect swimmers at recreational waters. These are the key provisions of the Beach Act. They authorize grants to implement beach monitoring and notification programs. Ensures that states have the most protective water quality criteria at their beaches, at their coastal waters, and requires EPA to study issues associated with pathogens and human health, and then to publish new or revised recreational water quality criteria based on those studies. So I'm going to go through each of these provisions. So authorizing grants to implement beach monitoring and notification programs. Approximately $9 million is issued each year to 30 coastal states, 5 territories, and 3 tribes to implement beach monitoring and notification programs. And these programs have been instrumental in allowing the number of beaches to be monitored. Previously, just a handful of states could monitor the beaches, and now there are more than 4,000 beaches monitored. So it's been a huge help. And since 2001, more than $120 million in Beach Act grants have been issued to states and territories and tribes to implement their beach programs. And what happens typically is a state will issue their grants to a public health department, which goes out and collects the samples, takes the samples back to the lab, analyzes them, and reports the results to the public, either posting flags or signs at the beach, and posting the information on the state website. Grantees are required to submit their beach monitoring and notification data to EPA annually, and this is done through EPA's beach system, the beacon system. It's Beach Advisory Online Closing Notification System. You can search for it, just EPA Beacon. It's a great tool. You can generate reports on your beach, find out the number or percentage of closures or advisories each year, find out about monitoring frequencies. You can do whole state reports if you'd like. It's really an excellent tool. And another requirement of the Beach Act is that EPA maintain this website. So the public is able to access this information. The EPA recommends that E. coli and enterococci are the fecal indicator bacteria used to measure water quality. And these are E. coli is the indicator organism used in the Great Lakes. And these recommendations are based on studies that EPA conducted in the 1970s and 80s, which found that enterococci and E. coli were better correlators of gastrointestinal illness than the previously used fecal coliforms or oral coliforms. And these findings led to publication of EPA's ambient water quality criteria for bacteria document, which I'll refer to as the 86 criteria. It's going to give you a little history on that criteria development. And then, 18 years later, EPA promulgated a rule which requires that those fecal indicators be used at all coastal recreation waters in the U.S. There's the second key provision of the Beach Act, which requires that states have the most protective water quality criteria at their waters. And that was to be done by April of 2004, hence the promulgation. In 1986, only about 14 states had adopted the E. coli or enterotoxic indicators, and EPA was directed by the Beach Act to promulgate the criteria, which we did in 2004. The third key provision of the Beach Act requires EPA to study issues associated with pathogens and human health, and to publish new or revised recreational water quality criteria by 2005, which was 5 years after passage of the Act. It was a very, very tight deadline to conduct all those studies and publish criteria. But EPA did a number of activities to lead toward publication of the criteria. EPA conducted with CDC a series of epidemiological studies around the Great Lakes and at marine beaches, interviewing beachgoers to find out what type of activities they engaged in at the water, whether they ingested water, played with sand, and then they called participants 10 to 12 days later to find out if they contracted any illness. EPA also conducted workshops. They invited a number of international experts to find out what types of studies would be needed to put into the recreational criteria development. And EPA developed a critical path science plan based on that information. And after conducting a number of studies, EPA published the revised recreational water quality criteria in November of 2012. And I'm just doing one slide on this. This is the revised recreational water quality criteria that were published 2 years ago. And they're very similar to the 1986 criteria. The main difference being there are 2 different illness rates that states may select from. And a statistical threshold value replaces the former single sample max, which had 4 different use intensities at beaches. And now, instead of including the beach number, EPA recommends a beach action value of 235 for E. coli at beaches, but it's not part of the recreational water quality standard now. I'm going to switch gears here and talk a little bit about the Great Lakes Restoration Initiative, which has been really key in improving beach water quality and improving public health at Great Lakes beaches. In 2009, President Obama pledged $475 million to address the most significant problems in the Great Lakes. And these are the 5 focus areas that were funded. So a lot of money, a lot of great projects. And the nearshore health and non-point source pollution category had 5 different areas that worked on improving beach health and improving protection of public health at beaches. And these are the 5 categories that were funded under that nearshore health and non-point source pollution category. And I'm going to go through each of these categories and talk about a couple of projects. There were so many amazing projects that were funded. I don't know if you can see this, but this is where all the projects were funded with the Great Lakes Restoration Initiative funding. You've got your annual sanitary surveys, mitigation projects, rapid methods, validation work, and your predictive model. So under the Improving Beach Monitoring for Bacteria projects, some entities would validate rapid methods, QPCR, IMS-ATP, which you'll hear about later, and they are able to test water quality conditions in 4 to 6 hours rather than the culture method, which takes 18 to 24 hours to come up with results, which obviously is a problem. If you close a beach when the problem is passed, or worse yet, if you leave a beach open when a problem may be, you may be exposing your swimmers to pathogens. Here's one example. The Northeast Ohio Regional Sewerage District, they studied 4 Lake Erie beaches using 2 rapid methods, and they validated this method, and they're using it at some beaches. University of Wisconsin-Oshkosh, they expanded existing lab facilities and established some new lab facilities to provide the capacity for Wisconsin to be able to monitor their coastal beaches using rapid QPCR methods. Assuming funding is available to do that. The communicating beach monitoring for the public. We get a lot of great tools out of this funding category. Automated text messaging services, The Great Lakes Commission, they developed a smartphone app so one can find out water quality information and weather info at all 8 Great Lakes beaches. It's an excellent tool to use real time. If you want to go to the beach, check out the site, find out if it's open. It's excellent. MDEQ and MSU work together to develop training materials on how to use the rapid method QPCR. They develop training manuals and a video so beach managers can pop that in and learn how to use QPCR. It's not that simple, but it's a really excellent tool. Under this third category, developing beach forecasting models, dozens of predictive models were established along the Great Lakes and tested, validated. And here's a couple of examples. WDNR, Adam, worked really hard on this project and ended up establishing 21 nowcast models at Wisconsin beaches. They also conducted a large number of workshops to train beach managers on this model. You'll hear more about this later, but the model uses EPA's free virtual beach software. And it's a great free tool to use. Good way to predict or estimate water quality conditions in real time, rather than waiting again for the culture method. It's a good alternative to the rapid method. This is just a photo of Chicago Park District's project, where they installed weather buoys and monitoring buoys and weather stations, and they are now using at all of Chicago's lakefront beaches predictive models to provide the public with real-time information on water quality conditions. Under these last two categories, conducting beach sanitary surveys to identify pollution sources and making beaches safer to implement measures to reduce pollution at beaches. These have been really key in helping improve Great Lakes water quality and protecting public health. This map shows where all of the Great Lakes beach sanitary surveys were conducted, and with the funding, 488 Great Lakes beaches were assessed using sanitary surveys. And this is really important because you'll hear all about this later in several talks. The next one that follows is going to go into detail, but you need to know what's happening at your beach to identify sources of pollution so you can actually go ahead and take measures to keep the stormwater off the beach, other contributing sources, keep that pollution out of the beach water.
Hey, Holly, I'm sorry. I'm just going to interrupt you for 1 second.
Absolutely.
I know that BP's driving everybody's crazy. It's driving me crazy. I'm trying to figure it out. Can I grab that off your
Yeah,
your lapel there? I'm just going to switch mics here really quick, and maybe that'll help. So
Sure.
just hold on. Bear with me. I don't know if this is it.
I thought it was questions coming in.
Oh, no. It shouldn't be. So I know it's driving everybody's crazy. Sorry about that.
No, it's fine.
Let's see if that helps.
Anybody have any questions while we're taking a break? Do you guys like the Baby Ruth that Shannon distributed? If you remember the movie.
Mm-hmm.
We were thinking about showing a little video clip of that, but it might be a little too early for that.
Okay. I think that might have done it.
Oh, great.
I'm sorry about that, everybody. Okay. So we're going to try a new mic, too, because
Oh,
we're hearing from our webinar audience.
Great. Let me just hold it.
I'll make sure. No, I'm going to try to do it like that, and this
Got it,
should
got
be
it.
sensitive enough.
Okay.
We're going to try to switch mics around here real quick
Sure.
and make sure that we get everybody on where they need to be on. Okay.
Happy to be the guinea pig.
Sorry.
No, it's no problem. Oh my, what a view.
There you go.
Oh, great. Okay, great. Thanks. I'm actually almost done. Shannon, you're up really soon. So back to sanitary surveys. I'm sure most of you are familiar with this, but EPA has, if you go onto EPA's Beach Watch website or just Google EPA Beach Sanitary Surveys, you can pull up these forms. But the routine sanitary survey is used to collect, when one goes out and collects samples to measure precipitation, you record information about the beach that day, temperature of the water, the air, wind speed and direction, number of bathers on the beach, algae present, birds present. And the annual sanitary survey is used to assess the surrounding watershed, find out what sources of pollution may be contributing, the slope of the beach, bathroom facilities, animal feeding operations in the area, septic systems, and other items. The EPA created a beach sanitary survey manual that you can use when conducting your sanitary surveys that describes the process in detail. In 2011 and 12, the Great Lakes Restoration Initiative funded 65 projects to start addressing bacteria sources at beaches through best management practices and other measures based on sanitary survey information that was collected during the 2010 sanitary survey plans. And I'm just going to give a couple of examples. There's so many great projects. I just kind of randomly selected some. Here is one that was done by University of Wisconsin-Oshkosh and Door County Soil and Water Conservation District. It's Egg Harbor Beach, which was low and flat beach. Didn't get a lot of visitors, experienced a lot of water quality standards exceedances. They came in, regraded the beach, added some rain gardens and permeable pavers, and stormwater is now filtered through the native plants, and the birds stay away. Not as many birds attend, but the attendance of the beach skyrocketed, so that was an added benefit. Really a dramatic improvement at this beach, which I think you're going to hear about later. In Hancock, Michigan, they did a similar project. They were affected by stormwater problems at the beach. So they added rain gardens, curb cuts to the rain gardens, which filtered the stormwater, added more permeable pavers. Hardly any water quality standards exceedances now. It's been a great, great project. Thank you. Just, I think, 2 more slides or maybe one.
Go ahead.
Okay, great, thanks. And this is another project you're going to hear about later from Pam Stropolino, but this is University of Toledo. They constructed a 10-acre wetland to help filter bacteria, sediments, and nutrients from impacting the Maumee Bay State Park beach, and it's actually helped reduce water quality standards exceedances at that beach. So our goal is to stomp out E. coli. And I'm going, oh yeah, so I don't know. That's Dr. Sam Dorovich. That's Kathy Breitenbach next to him from Chicago Park District. Michelle Caldwell from Indiana Department of Environmental Management. And Shannon Briggs, who's up next to talk about beach monitoring. If you have any questions, do you want to save it to the end and then we'll, okay, let me just introduce Shannon Briggs from Michigan Department of Environmental Quality. Excellent, thanks.
All right, Jim, do I talk right here?
Yeah.
Okay, sorry.
Yeah, take it right there.
Okay. All right, so if you guys can hear me, there's some jazz music in the back, so we've asked to have that turned down. So if that's bothering you, we'll get that turned down in the back. So I don't think the webinar audience can hear that, but there's some people dancing in the back of the room. And I'm going to move on to the next. So I got to reload that, right? Go right here. Yep. Well, again, good morning. Okay, I'm Shannon Briggs from Michigan DEQ. Thank you again for coming to Traverse City. Actually, we are in Acme, Michigan, which is kind of funny that, you know, if you grew up with Coyote and Roadrunner cartoons, you remember Acme. You could buy a lot of things from Acme. Hopefully while you're here, you also find a lot of nice things here in Acme that you could buy. We're enjoying right now, you'll be able to see some of the Grand Traverse Bay. We have the really nice windows here, and so that's really nice. We kind of argued for this room, so we're happy to be up here enjoying. When you're inside all day, it's really nice to be able to see outside. So the other thing I want to tell you about a little bit is Sleeping Bear Dunes while you're here. How many of you have heard or seen, are familiar with Sleeping Bear Dunes? Okay, most of our people here, if you haven't, it's really worth the travel to go over to the Sleeping Bear Dunes. This is the standard picture. When you stand at the top of Sleeping Bear Dunes, this is what you're going to see. You cannot see the shore of Lake Michigan from the top. You kind of have to venture down a little bit. And then be careful, because if you venture down, you go a little bit further and a little bit further. I think it takes at least 2 hours to get back up. So it's a 2-hour trek up. And if you do it at sunset, you have the double burden of the sun beating on your back the whole way up with no water. So a few years ago, I used this picture because a few years ago we had a Instagram beach photo challenge. And this picture is the winner for day 8, which happened to be the best beach to take a long walk. So if you want to take a long walk, you could also go to Sleeping Bear and have a great day there. So we love our beaches. They're top spots to go to. And what we're going to talk to you, like what Holly explained, is why we do all of this work, all this busy work, all this funding and all these things to make our beaches better and safe. And that's because we love our beaches. So here's just some typical things that we go through when we're monitoring our beach, what it really looks like. So here's some field gear that you're going to want. You have to have sample bottles. You need to work with your lab. If you show up with a whole bunch of water at a laboratory and say, hi, here I am, here's all my water samples, they will not be happy with you. You need to have the bottles that they want you to use. So before you run out and start collecting water samples, you really need to partner up with a lab that you trust and develop a relationship so you can make the logistics go well. And trust me, they will not like you to show up with samples after 1 o'clock if you're using the co-alert and all this culture-based methods. Another thing you need is when you send your staff out, you need to give them some training. So coming here, this conference will be great. You also have to give them an idea of what they need to do when they're out in the field. So you want to have trained staff, and that cooler with wheels can be really helpful when you're lugging a whole cooler full of water around. The other thing you want to do is you don't want to just run out into the beach area and start collecting samples wherever you feel like it. You want to have identified monitoring points. Preferably, you're going to have them right in the swimming area because that's where people are going to be at risk. So you have to identify all those points that you're going to be sampling. Do not take random samples unless you enjoy looking at random data. So you just pay attention to where you're sampling. The other thing is some people say, well, if you go out there with your waders on or you just walk out there, how do I know I'm not contributing to the E. coli sample that I'm going to take home to the lab? So some people use a sampling pole. You can see what it would look like. And then also you want to make sure your cooler has ice packs. You want to keep your water samples cool. And again, where do you sample? You want to make sure you have that defined swimming area. It's very important. A lot of us use lat longs, the latitude, longitudinal coordinates, and we like them in decimal degrees. Or we like to go into that detail, but that's really important on these databases. So once you get your water samples collected, you need to have your schedule set up. Because if you're going to do one beach, that's fine. Go out early, get your samples, go to the lab. Let's say you have 10 beaches that you need to sample. Can you get all those samples collected and back to the lab within 6 hours of your first sample? Because you have a holding time. You have to make sure those samples get to the lab on time. Then the lab has about 2 hours to prepare your samples. So you have a total holding time of about 8 hours. You don't want to exceed that. So lab methods. Now you're in the lab, what kind of options do you have? Well, the traditional one is the culture-based methods that we've been talking about. The sample cost usually is about $8 to $20, depending on how you're doing it. The equipment cost, you need an incubator. I call it a steel meal, but you need the equipment. That was the end of the jazz music. So you need some of this equipment to do the culture-based methods. And that's about $5,000 to get your lab set up for that. The downside of this that we've all been languishing about, just going on and on about, takes 18 to 24 hours to get your sample results with a culture-based method. So that means today I'll collect the water sample and I'll tell you tomorrow if you should go swimming. And we're all very aware of it. It's very frustrating. We'll talk about that throughout this whole conference as to ways that we've gotten over that and how we deal with that. And one of the ways is to start looking at other testing methods. One of those is called QPCR. It's called quantitative polymerase chain reaction. It's expensive. A lot of us have been kind of dreaming about it for a long time because the startup cost, you're looking at least, it used to be about $70,000 just for the equipment. Well, the prices have come down a lot, which is very exciting. The reagents and the other things that go with QPCR have come down. And we're also looking at the idea of compositing some of our beach water samples. Now here's the variation as well. Some places, they collect single samples at their beach, and one single sample is what it would take to open or close the beach. That's it. In Michigan, we like to collect 3 samples per beach. So you'll have, let's say, left, center, and right. So all 3 samples must be collected. You can have those analyzed individually and then take a geometric mean. But another option that we're looking at right now and allowing is that you would take your left, center, right, all 3 samples, build a composite, and then run the analysis on that. And we can talk more about that later if you want to, say, well, you're not exactly doing the same thing. Yes, we get that. But there's some circumstances that we can do this, and it makes sense. The results will be very accurate and consistent. So the other thing that is on the horizon, some people are starting to use this out in California and also for the Asian carp. What we're looking for is measuring the DNA of these invasive species or the fecal indicator bacteria, Enterococcus or E. coli, or even some of the pathogens. So you're measuring DNA again. But with digital PCR, it's a little bit of a different format. It's still outside of my price range. It's very exciting. It's got some potentially could be less expensive than QPCR, but right now we're on the verge of just using the new methods coming out of EPA for QPCR, and I know that Rich Hogland is here and some others at EPA are trying to work with digital PCR, but it's a little bit more work. They're going to work all the bugs out of it before I start putting my hands on it. So monitoring costs for culture-based, we talked about that it's $8 to $20. But you got to remember, you're sending somebody out, you're going to pay them per hour, you're going to pay for gas, mileage, you got to have your car. When you're out there, you might as well do a sanitary survey. It is the most cost-effective way to really get some really great information. So when you're out there collecting a water sample, you need to write down what's going on. Did 5,000 seagulls just fly off the beach? That would be important to know. Do you have 10-foot waves crashing on your beach? That's another important thing. So when you have all these different variables going on at the beach, and then you have your water sample, you need to put all of that into context. And we're going to talk about that throughout this conference as well. And so that's what I'm trying to do right now is especially a few of you are here for the first time and you are like, here I am, I'm at the beach conference. Well, you're going to be trying to take a straw up to a fire hydrant to get a drink. And so what I'm trying to do is lay it all out for you, and then you'll be able to make sense and put this all together in perspective. So when we're talking about these costs and all these things, your average sample, with all this training and your computer, you got to report your results, talk to the lab. Anytime you go out and collect a water sample, it's going to be about $100. Whether just it's a nice round number, but that's pretty much what you're looking at. And remember when I said you have to report your results. In Michigan, all of our public beaches must have a sign saying whether it's monitored or not monitored, and if it is monitored, where people can find the results. So, this is just out, it's going to be there all the time. A lot of our beaches, they'll have a sign by the visitors entrance where you can go to find out immediately if the beach is open or closed. All right, so now I'm going to kind of walk you through. So here we are. We're going to pretend we're all the new beach monitoring person for our local beach. And what do you have to know? You got to find your beaches. When we first started this program, we didn't know where our beaches were. I didn't. How do you keep track of all those beaches? We even went and I talked to some mapping companies, and they didn't have it all. So you got to go identify all your beaches. And remember that part where I said you got to get lat longs, decimal degrees? It really helps to build your database when you have these accurate points. And again, it's going to feed into some databases. And we're going to talk about Virtual Beach, and Adam Mednick is here today. So if you ever have more questions about Virtual Beach, you want to talk to Adam, but I'm going to explain why all this stuff fits together. So you're going to identify your beach. You're going to get the location information. You also want to conduct a sanitary survey, just like you would for drinking water, for a well. You want to look at the surrounding areas, the watershed, kind of look at the slope of the beach. Is it a shallow slope? And the next speakers from 9 to 10 are going to talk about all those very important things about a beach. What makes a good beach, a bad beach, what attracts birds, what deters birds. So you want to look at all this information. There's also a way to collect the weather information, and that's through NDAT, but that's a whole other talk. We're not going to get into it that much because this is when you can start evaluating all your data. So remember, your E. coli results are coming in a day late. That's a real frustration. However, you can get weather data immediately. You can get your sanitary survey observations immediately. So when you get back to the lab, you can start plugging in all that information and create a virtual beach model, which will start forecasting your water quality results. So you use the E. coli data to keep it rolling along, but with virtual beach, you can start getting a prediction of whether your beach should be open or closed. And I think we're getting, some places are getting up to 80, 90%, over 90% accuracy, which is, it's better than better than me telling you yesterday you probably shouldn't have been swimming, because that's not going to help you. So virtual beach is a great step into the right direction. So let's say you've made it through this, you've identified your beaches, you've done your sanitary survey, you evaluated all the data, you're using virtual beach. Now you've got to ask yourself that question, do I have evidence of contamination? Are my E. coli results or enterococci results, are they high? What are my bacteria levels? So if your levels are low, you've got one of the best jobs all summer. So you get to go to the beach, you get to collect water samples, come back, put your data in, have some coffee, read emails, no big deal. Nobody's going to be mad, your levels are low, everybody's happy. Well, here's where the thing goes bad, and here's why a lot of us are in this room. If you have contamination, a yes or a maybe, now you're going to go down that side, the left side of the slide. Now you have a potential risk. Now you got to start thinking about what is going on. Why are my bacteria levels high? Why am I seeing this? This is bad. Trust me, mayors get involved, legislators get involved. You'll get to meet lots of elected officials when your beach goes bad. So investigations. Well, one of the first things you're going to have to do, you've got to figure this out. You've got to do your homework, do some more sanitary surveys. There's a routine sanitary survey. There's an annual sanitary survey. They have different level pictures of your beach. You want to map it. Look at upstream sources. Is there a creek? Is there a storm drain? What are all the inputs that are coming to your beach? Typically, at least in Michigan, most of our beaches are fine all by themselves. The problem that we have is that there's either going to be a storm drain or a creek or a ditch or a river that comes out alongside our beach. And that's where the storm water is traveling to our beach where we have some contamination. So here's where you want to go for some more information on sanitary surveys. Here's a really fun thing. This was a Made in Michigan start. We have some dogs that are trained to go sniff out sewage. And you're like, yeah, right, how hard is that? But these dogs are incredible. A lot of us have met them. I think I've met everybody except for one of the dogs. So what we do is you hire these dogs. They're trained to find human sewage. And when you're at a place where you don't have a lot of money, you don't know how to do DNA testing, you don't know how to do source tracking, then you need to bring in the dogs. Call in the dogs, go out. They're very effective. They're very quick. You can meet Logan and Sable. They're the first two dogs with Karen and Scott. You've got Aaron and Crush. Crush was just recently in Michigan. He's also a top agility dog. Stephanie and Kona, and then Dan and Abby, and Laura and Kenna. And I got to meet Kenna as a puppy. She's adorable. And I got to see Abby and Kenna play together. They're very rambunctious, very good. So they don't work together in the field yet because they like to play. So the dogs, you know, how do you miss? You got to have a slide with the dogs in them. So if you ever want to do beaches and you love dogs, this is a good combination. Another thing you can do, like I said, is the investigation. So you can use QPCR, the quantitative polymerase chain reaction, or the digital PCR, to help you find the DNA of these indicator bacteria or the pathogens, or we call them like source markers. It's going to be too technical. I don't want to go there. We got a whole bunch of talks coming. But basically, you can run these DNA tests to find out what kind of sources of contamination are at your beach. And here's some pictures of some of the sources we found. Let your imagination go when you think you might have a source. It's very interesting. You can use dye testing, smoke testing. The dogs found the pipe over the creek. So the sign, you see a sign in the ground with smoke coming out of it. Somebody put a sign into a sewer pipe and punctured it, so that's where some of that is coming from. You know, pictures of failing septics. They're not that obvious always, but there's one that is. The storm drain right up here, the culvert thing that popped up out of the beach sand, that was on our beach not very far from here at Bryant Park Beach. Sarah Uren from the Watershed Center, she would call me and say, Shannon, it's going to pop, it's going to pop. And sure enough, just when we got the GLRI grant, it popped. It literally popped up out of the beach sand. So I don't know why anybody would put a storm drain on the beach. They did, but now Sarah's used GLRI money and they fixed it. So you'll find a lot of interesting things. And one of our health departments said that they've kind of lost the wow factor. You know, they've been at this game for quite a bit. They've kind of lost the wow factor on things that they found. All right, so let's say you've done all that investigation. You've corrected some sources, you identified them. That's very important. Don't try to just cover something up. You've got to fix it. You've got to work with your health departments, identify sources, and correct them. But now you've got another option of remediation. Some beaches need to be altered, and Greg and Kim are going to talk a lot about that. They've got some excellent stories about how they've adjusted some of their beaches to be almost invincible to stormwater and other problems. But with remediation, it's easy to come up with a $20 million bill. You can easily go into a beach and say, oh, let's do this, this, and this, and this. All right, well, that's $5 million, that's $200,000, and then the bills just add up. And you got to be careful because you don't want to just blow your budget, okay? So we want to blow up E. coli. We want to get rid of the E. coli. And I put this in because we're in Acme, Michigan, so you can buy a lot of things from Acme. But you got to be careful when you're doing these remediation plans. If you can fix the beach just by simply grading the slope of the beach, then you don't need to put in a $2 million super system with filters and whatnot. So you got to think about what's going on, use some common sense, which is great. You're in a room with people who have done a lot of projects that have a lot of great ideas. You're going to hear a lot about them, I think, on Thursday or Friday, but they're coming. So these are some pictures in Michigan. The picture on the side here, you've got a sidewalk, some rocks, a rain garden, and then the beach. This is a nice little filter, so as soon as it rains and all the rain hits the sidewalk, which is sometimes covered in bird poo, you don't want that all rushing off into the beach water right away. So some of these berms, these rain gardens, are excellent ways to keep storm runoff from getting right into your beach water. And again, here's some more pictures. Rain gardens, a lot of people are putting in rain gardens. Tall grass is your friend. So a lot of beaches will have a nicely manicured grass right up to the beach, and it's all lush and it looks pretty. You'll notice it'll attract geese quicker than throwing out pizzas and Cheetos. So your geese love wide open spaces, lots of grass, lots of beach, and water. So what we've been doing is you put a little bit of landscaping grass that grows tall between the line of sight of your nicely mowed grass and the water, and now you've created kind of like a barrier, and the geese don't like it as much. And it's working. Just be creative. More people are going to talk about that later today. All right, so now we've almost made it around full circle. So you've made it through your investigation. You've talked to some people about some remediation ideas. Now let's say you've got your beach back in good shape. What are you going to do? Hopefully, you'll continue monitoring, keep an eye on it. You can reevaluate it, and you just keep going through the loop. So if you do your job, and you may have to put in some hard work at the beginning, you might find that over time, you'll spend more of your day going through, there's no contamination. This is an easy job. I love it. I love going to the beach. Everybody's happy with their beach, and you spend a lot of time there, and then that's a lot of fun. So I'm just going to end with the Great Lakes Beach Association website. This is where you can get all of this information, past presentations, connecting to other people. The BeachNet listserv is on there. And if you talk about a BeachNet listserv, what is that? It is our way of staying connected throughout the year. We love coming together here for these meetings. This is where we all get together, compare notes. So during the day, you're going to hear all the success stories. At night during dinner, that's when we share all the things that went bad and didn't work and we had no idea they were going to break. So here's where you can connect to at least 1,000 different people across the world. We have our friend Callum in Scotland and Zhao in Portugal. I'm going to forget some people. Graham McBride, New Zealand. Got friends in Australia, Canada. We got to say hi to Tom Edge, Sue Watson, all the friends in Ontario. And I know that hopefully they're listening on the webinar. So we have a lot of different people with a lot of different expertise, and it's a great place to post questions. And so thank you again for coming, and I think we're going to go with questions now. And so for the webinar, we'll check questions there. But for now, we just have questions from the audience, and then we're going to get set up for the next speaker at 9 o'clock. Oh, yes, okay. And Holly has one thing, not for the webinar audience, unless you want to mail her.
Right. Getting a lot of mileage out of this. This is a beach mitigation DVD and examples of some excellent projects that were implemented in Wisconsin based on sanitary survey findings and some of the work that they did to improve water quality at their beaches. And I think you'll like it. It's great. So I have probably a couple dozen copies. If you want one, please grab one. Thanks.
So we have 10 minutes before our next speaker starts. Do you guys want to take a break? Do you have questions? Y'all starting to wake up? What's that? Oh, we're looking at it. What's that? Yeah, right. Yeah. I think that's great. Good. She wants it? Yeah. Yeah. Cool, okay. Oh, okay. I found on me was, but you know what, you go. Let me see if we can, should I use this mic for the webinar? Okay. All right, there is a question from the audience on the webinar. And okay. Do you have any pushback to grooming beaches or grading a beach for ecosystem concerns? These will help with bacteria but harm beach ecosystems. Could speaker put up the second to last slide so that we can get that website information? All right, so I'll try to put that one back up. All right. Yep. All right, there was one question from the webinar audience. You guys can keep talking, but so the question was, when you do beach grooming, do you get pushback that you're ruining the ecosystem, that you're harming the area for the beach and the habitat? Greg or Kim, do you guys want to answer that? When you do beach grooming, when you're grooming your beach, do you get pushback that you're harming the ecosystem or the habitat? But you got to come this way. Here's the webinar mic, and here's that audience mic.
So we've had that question a number of times, and usually we approach it via some education. So utilizing beach grooming, you can sort of manage the amount of vegetative growth on your beach, but you're usually not grooming, or you're not supposed to be grooming over any existing vegetation. It's usually where sand exists, and then the extent to which you groom will deter additional plantings from growing or encroaching on your beach area.
Is there another question?
Yeah, did you want to read off the questions from the webinar?
Yeah, we can do that.
Yeah. Okay.
That was it? Okay.
Just make sure you repeat all questions to the webinar audience can hear you.
Yep.
Okay.
All right, so for our webinar audience, that was the only question we had. I think that's it. And now we're going to take a break until 9 o'clock to get the next speaker. Right, do you want me to stop recording? No, I do that by... Okay, clicker. I think I got the mic on, and this is working. Okay. Okay. When you speak here, this should kick it there. Okay. Our next speakers are from Wisconsin. Can you guys hear us okay? All right. So Kim Busse is from Wisconsin, and I'm going to let her just get into it for the webinar audience so we can stay on time. She's going to talk to us about the sanitary surveys, more about the investigations of what's going on. There you go, Kim. Thanks.
Thank you, Shannon. Oh, good morning. As Shannon mentioned, my name is Kimberly Busse. I am from the University of Wisconsin-Oshkosh. Seems kind of weird. We're not actually located on a Great Lake, but we do a lot of work along the Great Lakes. We have 4 regional labs located on Lake Michigan and Lake Superior. I was just thinking about this. This is my 8th beach meeting, so I'm kind of excited about that. Been coming for a long time as a student and now as a professional, so this is really exciting. So we're going to take one step further. We had a great talk on Beach 101 from Holly and Shannon, kind of giving you the nuts and bolts on routine monitoring and the steps that go into that. And we're going to move on talking about beach sanitary surveys. And again, this is the sort of the investigative piece to beach monitoring. So identifying potential sources of contamination at your beaches. So we're moving from monitoring to actually tracking potential sources. So routine monitoring provides sort of the status or the water quality status at your beach. Again, if the beach is impaired or under exceedance, that's great. We can let the public know that and inform them, but we want to know why. So that's kind of what the beach sanitary survey question or answers that particular question. So I wanted to give you a little bit of history. Here's Wisconsin. So this is where we're located, UW-Oshkosh. But we have a number of different labs located in Door County, which is really similar to this area, actually. We were just talking about that. Lots of wineries, lots of good tourist attractions. So we monitor 40 beaches in Door County. We also monitor locations in Manitowoc, and we've done a lot of work up in Lake Superior as well. So quite a bit of coastline. And our cohort, Julie Kinzelman, who couldn't be here today, monitors a lot of beaches in the southern region. So to give you a little bit of background on the sanitary survey tool, before it was called the sanitary survey tool, it was primarily just investigation. So back in 2003 and 2004, Racine developed something like the beach sanitary survey tool, where initially it was just investigating, collecting samples at potential sources that we thought may be an issue. There was really no defined process. So that might be collecting spatial samples, collecting additional samples to try and pinpoint from the direction of where the sources of contamination are coming from. It may be just writing down different parameters, as Shannon mentioned, about environmental parameters, wave height, but there was really no clear, concise process. But we were starting to do this in Wisconsin back in 2003. In Door County, we began investigating potential sources at 10 beaches using similar principles of the current beach sanitary survey. So again, that's collecting samples, just investigating sources that we think were issues, but no clear, concise process quite yet. In the summer of 2007, the US EPA awarded pilot studies to investigate 61 beaches, and 20 of which were in Wisconsin. So that's the first year where we actually had a form and a process of performing these routine sanitary surveys. And then in November of 2007, the EPA compiled all of these results at 20 beaches in Wisconsin. So this was the first time that we really went out and used a specific tool for investigating sources. Then moving forward, the beach sanitary survey was used at over 40 beaches in Wisconsin from 2010 to 2014, and that's, as was mentioned earlier, the Great Lakes Restoration Initiative funding came to us where we could really use this tool at a wide array of beaches in a short amount of time. So something that was very interesting as part of this process was that initially when we were developing the beach sanitary survey tool, it took many years. So maybe one year we collected some investigative water samples, maybe wrote down how many birds we saw that day, and then the next year we said, okay, well now we should probably look further. Maybe we went upstream and monitored at some outfalls, but it was a very long process that could take anywhere from 5 to 10 years from the time we were investigating to actually mitigating some of these sources. And a lot of that had to do with funding. So maybe we would get $50,000 here, $50,000, the following year to do pieces of the puzzle. And the Great Lakes Restoration Initiative gave us that funding piece to do a lot of work in a short amount of time. So that went from 5 to 10 years down to 3 to 4 years, where we were able to investigate sources, develop plans to hopefully fix those contamination issues, and then mitigate. So that just gives you a little bit of background. It wasn't always the sanitary survey tool was not always there for us, and we're really happy that it is because it really streamlined what we were trying to do. So Shannon had a great diagram, so this is kind of the same thing, but we'll with one additional step. So looking at beach mitigation as a stepwise approach, this is how we kind of approached beach mitigation in Wisconsin. We ended up investigating, I think, over 50 beaches as part of the GLRI projects in the last 5 years. So we needed to have a streamlined process because we were doing so many beaches to try and investigate them in a logical way. So the first thing that we would do is evaluate historical water quality. So again, collecting all of the data that might have already been done with the routine monitoring, especially we had a large database. So it's compiling the data, understanding the beach characteristics historically. Then the next step is to actually visit your beach, doing what we call an initial site assessment. And that can be as simple as walking up and down the beach, looking at beach characteristics that are very obvious. Maybe there's a storm sewer that's flowing directly on your beach. Maybe it's a little less obvious, looking at the parking lots, the roadways, what could be interacting with your beach that could be contributing contamination sources. So it's great to have a lot of data. It's really great to look at those numbers in an Excel spreadsheet, but until you really visit the beaches, you can really get a better understanding of what could potentially be going right or wrong at your beach. The next step is performing the sanitary surveys, and I'll go into that in a minute exactly what the sanitary survey is, but investigating potential sources at your beach. And this could take anywhere from 1 to 3 to 4 years. We typically like to collect more than one season's worth of data. And the reason for that being that we want to ensure that we're not just seeing a particular anomaly one season, if that was a particularly wet year or dry year, etc. So we want to have multiple years of data. The next step is then developing a beach redesign plan based on the sources that we identified during the data collection. So we want to ensure that the improvements we're making at the beach are being helpful and not harmful. So we want to make sure we have enough data before moving forward and that our beach redesigns are addressing the potential sources that we previously identified. Then the next step is mitigation, if funding permits. So that's usually the most exciting phase, and we have some great examples of that today. And then the last piece is what I've even done here, blue investments, but the economic benefit. So we wanted to hit today not only on all of the investigative pieces, the mitigation, but how not only water quality improvements help the health of your beach, but also the economics in your area. All right, so this is, I'm just going to take a step back and just discuss what are sanitary surveys, because we keep throwing around the term. The sanitary surveys are an affordable, simple tool to evaluate potential sources. So we're considering a number of different environmental parameters. We still collect water samples, which is really important, but we're trying to take in a number of different other parameters that we can correlate with E. coli to see if they are having an impact. So the top form is kind of hard to see, but this is a routine sanitary survey form. These are just 2 pages, front and back. Very simple to fill out. It takes approximately, depending on your beach, anywhere from 30 minutes to an hour to fill out and collect all of the data and information that you need. Very limited equipment. We have typically we bring out a thermometer, an anemometer to measure wind speed, and current speed is actually measured with an orange. So tossing an orange in and measuring the distance it travels. So we can fit everything into a backpack, so it's pretty not very intense. You can ask some of my students back there if they feel the same way. But fairly simple to carry out and very inexpensive. A few bags of oranges, I guess, if they don't always go get. But that's really it. The second piece to this is the annual sanitary survey. So they're broken up into two different categories. The routine sanitary survey is done every time you go to the beach. So if you have a high-tiered beach where you're going 4 days a week, you can conduct this survey every time. And it's best to do it every time you go to the beach, even on resampling days, and those are probably the most important when we're seeing issues. The annual sanitary survey is done annually, once a year. This is a little more extensive. This is an 8-page form, and this does not only look at characteristics directly on your beach, but taking a step back and looking at your beach on a watershed level. So looking at impacts, what type of land usage is occurring where your beach is located. That might be miles away. Identifying different streams and creeks, things that could be contributing outside of the scope directly at your beach. So we take a look at that annually. We also look at taking different measurements at the beach to see if the landscape has changed from year to year, et cetera. So it's just a little more comprehensive. Here's an example of some of the environmental data that we collect using the routine sanitary survey tool. The form is broken up into a few categories. The first is your general beach conditions. So we take things down or record things like air temperature, wind speed, rainfall, weather conditions, whether it's sunny or cloudy, the current speed, direction, wave height. Again, very simple things to record, but this just gives us an astronomical amount of data to work with. The water quality characteristics, so again, just collecting your water samples. For several of our beaches, when we were doing our initial assessments, what we consider collecting baseline data, we did multiple samples at our beach where we did spatial sampling. So we collected up to 9 or more samples at the beach at different transects and at different depths. And we did that to understand the concentrations of E. coli in the near shore moving out. And if we had impacts such as stormwater outflows at the north or south ends of the beach, those samples would kind of give us an indication if the water quality was being affected by those potential sources. But you can collect samples, however, each beach might be different. We did this sort of spatial sampling, again, to collect a lot of baseline data and then targeted in specific sources each year as we were able to identify them. So this can definitely change from year to year or even during your sample season. Water temperature, the color, the turbidity or clarity of the water is also really important to collect as well. For turbidity, we can do this directly in the field or collect a water sample and bring it back to the lab and analyze it there. Then bather load, so the total number of people at the beach. So that's generally pretty important, how many people are on the beach and actually in the water to make that distinction. And then identifying other potential pollution sources. So these might be really easily identified, sources of discharge, rivers, outfalls, wetlands, other things in the water, debris. What type of debris is on your beach? You can learn a lot from the debris you find on the beach. So whether it's very urban, if you're finding lots of garbage, you know that that it's probably heavily used by people. If you have a very rural beach, you might just see a lot of brush on the beach as debris, campfires, whatever that you might see. So the type of litter you find will tell you a lot about how people are using the beach. The presence of wildlife, so Shannon had a good picture, I think, before of a lot of geese and gulls at the beach. And then the presence of any other animals, whether you see dogs, horses, it could be anything. Really taking into account and make sure you're documenting all of that so you understand how your beach is being used on a daily basis. Here's some examples of things that we take into consideration on our annual form. I didn't mention this, but the annual form also serves as a sort of an endpoint for all the routine sanitary survey data that we collect. It's all summarized on this form. So it gives us an opportunity to analyze our routine data, put it into one place where we take into our physical characteristics, and we can also make some conclusions based on our data from that summer on this form as well. So we, again, as I mentioned before, looking at land use, so kind of going outside of the box a little bit, are there any potential septic systems that may be leaking, or et cetera? Rivers, creeks, and streams, agricultural runoff, again, marinas and harbors. So looking outside of the scope that typically is just the beach, looking outside of that. Landfills, we've had actually a beach located up in Superior where we've had an issue that we didn't know a landfill was actually there. It was not capped properly many years ago, and we had issues where contamination was happening for weeks. The beach was closed, and you know, this, not for sure, but that could have been a really potential big problem. So those things aren't always obvious, but over time, hopefully they become apparent. So talking about the annual survey, this is just a beach located up in Lake Superior. So I was told I can't use my hand to identify any place in Wisconsin because I'm in Michigan, but here it is. So Thompson's West End Beach is right at the top, located on Lake Superior. And this beach, again, just showing you is an example of looking outside of just the beach. So the beach is located right here. You can see that there's a pretty significant pier. This is actually, part of this is gone now. That restricts water flow. There's a wastewater treatment plant located here. Thompson's Creek, which is, again, you can kind of see the plume coming out. The city of Washburn, the city is located, there's a pretty significant hill located here. And a majority of the stormwater, at least from a portion of the city, all runs right down to our friendly beach here. And again, if you don't look outside of this area, you would not understand some other characteristics that might be really important that are having a big impact on our beach. And Greg's going to talk about the remediation at this beach later, and mitigating some of that stormwater and getting creative and how we fix some of that. This is just another example, again, of the same beach. So looking a little bit closer, these black dots are just stormwater outfalls right here. But again, the stormwater at this beach flowed, actually I think if I click through here. Okay, so when we did the annual survey, we also took the measurements of the beach. We measured the slope. This is a very flat beach. We noted that there's the pier that jets out, but again, this is gone. This is an old photo. It's kind of fell in, removed. Then there's boat dock. Again, the storm sewer pipes, and then the stormwater flow from the city. So we met with the city multiple times, trying to understand how the stormwater was flowing, and had to do some more outreach to find out some of that information. So as we perform these routine sanitary surveys, the annual surveys, we want to follow a logical and defensible process, meaning that we want what we're doing to actually make sense. So we must use actual data to make decisions. We want to have make informed decisions based on a robust data set. No two sites are the same. As we did this, that is definitely true. We've looked at over 50 beaches, and definitely not one is the same. There's a lot of synergies as far as things that we can do to improve water quality between some of those beaches, whether they're urban or rural, but they're definitely not the same. And not all sites need remediation. So you can see this picture on the bottom. This is at Kohler Andre State Park. Beautiful beach, not very high levels of E. coli. Naturalized dunes, a good slope at the beach. You can see it's very dry. Didn't need remediation, but the sanitary survey tool also told us that we had good water quality at that beach. And we also want to use our limited resources as efficiently as we can, and I think everybody in this room has probably done that one way or another. So the ultimate goal of our sanitary survey tool is to explore and accurately characterize beaches Great Lakes beaches in terms of possible sources of microbial pollution entering the beach area. We want to find out why this is happening, why there are beach closures. So some potential sources, you guys hit this up pretty good, but I'll fly through these. This is at Whitefish Dunes State Park in Door County. So again, we talked about this, people, wildlife, this is big in Wisconsin, right? Dogs, geese or waterfowl, and other wildlife might be present at our beach. The potential sources can really be broken up into two categories, however. There are point and non-point sources. Point sources would be things that you can really easily identify, so those could be a known source of discharge, so sewer pipes, stormwater discharge tiles, those types of things where you can accurately point them out. The non-point sources are things that are harder to identify, things like tributaries. We're not exactly sure what is going in there at every point in the tributary. Rain, sheet flow, birds, other lake conditions, etc. I thought this was kind of interesting, and I wish I had both figures up here. But this is sources of beach water pollution in the United States as of 2012. Before this, in 2007, this was upwards of 90%. Of unknown sources, so this purple is actually sources we have not identified. So just to 2012, this dropped almost in half, and it's probably lower now. I mean, I'm pretty sure. But then the next category is stormwater. So that is probably at any urban beach. Stormwater is likely going to be a potential source of contamination. Wildlife in the red here, and then sewage overflows, which you don't have a whole lot in Wisconsin. We only have combined sewers in Milwaukee still, but that's at 10%. And then, again, this number is still steadily declining with unknown sources because I think our beach team is doing such a great job at identifying those sources. So I'm just going to flip through a few photos here of some examples. This would be a point source discharge. I can walk in here. So this is really large. It's like 10 feet tall. And this is on a dry day. So we might have some issues going on here. And then this pool is great for little kids. They really like to swim in here. It's really warm, but very high levels of E. coli here. Yeah. Here's another one. This is at a power plant. This beach is called Warm Waters. I don't know if you can tell why. Again, lots of pooling. This is not Lake Michigan yet. You have to actually go pretty far out before you hit the lake. Here's an example of a tributary. The beach is actually right here, but very rural. I don't know if you know what that one is. Yeah, okay. A few gulls on this beach. This beach is about a half a mile long, so it's really a large beach, beautiful beach. But they have a lot of issues with birds. Here's another one. Geese. Also, I had mentioned this. Algae, while it's not a source, it tends to harbor bacteria. So this is Cladophora. This beach, again, has a large jetty or pier that extends out, which traps a lot of this Cladophora on the beach. So when we're doing our routine surveys, we take into consideration how much algae is on the beach and in the nearshore water, what it looks like, what's the color, whether it's sitting on the beach for a long period of time, the color changes. I've seen it when we did one of our studies a few years ago in Door County, where we should have been on Dirtiest Jobs. You guys watch that? Like, we would have qualified. Walking in the algae and it's bubbling up black and getting slapped in the face with it. So another example, here's a great example of stormwater. So you can see this was just, I think it was just got done raining when we were at the beach. So there's pooling on here. You can see the stormwater flowing through the beach. There's no buffers. There's a parking lot behind here. All turf grass flows right through onto the beach and into the nearshore water. This one was kind of like point and non-point source here. There's a pipe here, but it's all overflowed and it's flowing right into the water here. I don't know, can anyone guess what that is? This is one of Greg's favorite pictures, so I just had to put it in here. Anyone get it? This is a pig, this is in Superior though, so not on Lake Michigan. We're good. Yeah, and you can see that. So always something interesting that we find at the beach. Could be anything. Do you want me to just leave this up for a while? You guys got a good look? Okay. All right. Let me know. I can come back to it. Okay. All right. So those are just some examples. We have thousands of photos that we could show you. We really like showing pictures. Greg will show some more in a minute. But I wanted to give you a little bit of background on the Great Lakes Restoration Initiative in Wisconsin because it's been a pretty exciting story. Our group, and again in conjunction with Dr. Julie Kinzelman, who's not here, we were awarded over $3.5 million through the GLRI to do a few things. As I mentioned before, we're doing sort of this stepwise approach to beach mitigation. The GLRI sort of guided us in this way where we started out collecting baseline data for 3 years at 40 impaired beaches in Wisconsin. So this is just part of this project. 16 additional beaches that were not impaired. And then we also evaluated 2 inland beaches. So can we transfer the beach sanitary survey tool to inland lakes as well? And through this, we found out we definitely can. We also developed 4 fully functioning rapid testing facilities that Holly had mentioned before for QPCR. That includes infrastructure and equipment at these locations. We developed, so the next step, so we collected all of our baseline data. This was over 3 years. Some beaches we did 4 years of baseline data. We then used that data to develop over 30 beach redesign plans as part of this project. Again, you can see all these dots on here. So red is routine sanitary surveys, yellow, they're all just kind of mushed together. And then yellow is redesign plans, and blue is the mitigation, beaches that were actually mitigated. We implemented 9 of these redesign plans as actual mitigation in the north and southern regions, and 2 up on Lake Superior. Collectively in Wisconsin, though, we were trying to add this up last night on how many beaches we've done beach sanitary surveys, redesigns. Over 70 beaches we've performed beach sanitary surveys on in Wisconsin, 50 beach redesign plans, and 25 beaches that have actually been mitigated. So we were really excited about those numbers. Additional funds, I wanted to mention too. So again, the GLRI allowed us to do a lot of work in a short amount of time, but we couldn't have done a lot of this without other sources of funding as well. Through Wisconsin Coastal Management, Sea Grant, EPA Green Infrastructure, local municipalities. Greg will talk about this in a minute, but how we cobbled together different funding sources to make these projects a success. And here's our partnerships. We looked up a slide last night too, where the partners, there's like 3 of them, and this was like 4 or 5 years ago, and it's just grown. So we continue to build partnerships, work as a team to accomplish a lot of these projects to get them done. And I'm going to turn it over to Greg.
All right, Greg. Thank you. There is no doubt Kim is number 1 in the number 2 business. I want to back up a little bit. Education, we're at an academic institution, and certainly this is our business, our core mission, right? And the question can always be asked, why do we do the things that we do? And part of it's training students. The other part is, I don't want to be the one that the rain gauge calls at 2 a.m. anymore, and I have to go lift some manholes and catch basin covers and collect samples. But when we head out to any of these communities, even though we think we come up with a really good idea in January, there's always challenges, and there's always a lot of internal politics and educating of people. And as I go through the next few slides, I want to back up a little bit to what Shannon and Holly talked about earlier in terms of monitoring, and what Kim just mentioned in terms of sanitary surveys and why we do this. When we started this, Wisconsin implemented the Beach Act monitoring in 2003. In 2002, we had a waterborne outbreak of disease in Door County with about 70 people becoming ill. Nobody died, but it was fairly significant. We're pretty famous for waterborne outbreaks. We're the biggest one in the world. or in the U.S., yeah, in Milwaukee, right, crypto, so it's our claim to fame, I guess. But once you live through that, the county made a decision. They can, and Door County, just for those of you that are not familiar with it, would be a mirror image of looking outside of Traverse City. A lot of orchards, a lot of tourists, very high property values tied to the water. And so that's an integral part of not only their society, their culture, but also their economy. And so the county made a conscious decision and said, we don't want this to happen again. How can we be proactive? And as Kim pointed out, and as Shannon and Holly talked about all these different methods, we did things with antibiotic sensitivity. Everybody thinks DNA is really sexy. We got to do DNA. We did a lot of that, 10,000 samples trying to source track things. We spent a number of years piecing data together with small little projects to try and answer one large question at a number of beaches. The Sanitary survey tool, I can't emphasize enough how important I think that is as probably the first most cost-effective way to identify the pollution sources at your beaches. And as Kim said, it's allowed us to sort of put a comprehensive monitoring program together that's comparable from location to location. And out of the 110 beaches we've worked on, there's not any two that are alike. Some share some similarities, but none of them are the same, and we can't apply the same principles even from one location to another. So having said that, I'm going to talk about a couple of case studies in Wisconsin, and if anybody wants any additional information, we're now at the point where a number of these have been done over the last couple years, and things are basically ready to show off. And what's the first question? We've done all this work. We've identified where we think a large majority of the pollution is coming to the beach. And one other little background piece, as Kim mentioned, in Wisconsin, there's only one municipality that has combined sewers, and that's in Milwaukee. So most of the locations we deal with are exactly like this. Out of the couple hundred beaches in Wisconsin, the vast majority are what I would call rural or semi-urban, so towns of 20,000 or less. And so it's a tremendous number of those, but that beach is much more integrally tied to that community than one in a large city when you look at the number of people, right? So if you have a town of 200 people and you have 200 people at the beach, that's a pretty, and I'll show you an example of that in a minute, but that's a pretty big impact on those small communities. So what's the first question a municipality would ask? You've identified the source, you've come up with some ideas on what you might want to do. What? Yeah, exactly. So how much does it cost? And that's always the big one. And so this is just an example of what a cost estimate for beach remediation. In this particular case, is $95,000. This one has actually been done. And so I would call this a moderate to low cost beach. We've had some come in at $4 million. And then the communities decided, well, maybe we don't need the pavilion and the gazebo and all these other sorts of things that people just add in those meetings. But we've also done one for as low as $45,000, so a very small beach. And if you look at this, the communities, what we tell them, and we'll show you some examples. For example, native vegetation, dune grass planting. I think the meeting in Sheboygan, Wisconsin, we did a dune grass demonstration of planting in the rain. And that was pretty interesting. So it's really pretty simple. We have many cases where a master gardener, a local group, a municipal group of employees, whoever it happens to be, will donate some time. And it's sort of like, I look at it like you're building a house, and you look at this and go, oh, yeah, I can put up some fixtures. Oh, I can paint the walls in this bedroom. I'm an amateur electrician or whatever it is. And you can start taking costs off of these. And each municipality or town may be able to bring some value to that to bring the cost of this done. But this is really the first step. Come up with a really good cost estimate of what you have to do. And then from there, you take a look at the site, and then how can we implement based on what we have to what we need to do at that particular beach. The other thing I will say, as I show you these, as was mentioned earlier, there's a couple approaches you can take. You can take an approach where I'm going to put in a lot of hard infrastructure, a lot of what I'd call hard engineering solutions. They may work very well. They're extremely costly. They also contain the possibility for extremely high operation and maintenance costs. And imagine in these small municipalities where these towns are, or even in a county park where they have a large area to cover, O&M costs and just effort by employees is a huge issue. So we took the approach, County of Door started this again, that we wanted to have sustainable long-term infrastructure that would sort of renaturalize locations and bring them back to, in many ways, the way they were in the past. And as somebody said, I think brought it up, why would somebody put a storm drain on a beach? Does anybody know the answer to that? I can only guess, but I've talked to a number. I mean, if you're putting in municipal infrastructure and you have stormwater that you have to daylight at some place, are you going to do sort of eminent domain and bulldoze somebody's house? No, you're going to go to the public point of access at the beach in the municipality, and that happens to be the beach. So over decades, that sort of infrastructure has just evolved to where we've had beaches where there's 3 pipes, literally 3 stormwater pipes draining an entire city to one beach. And does that really make a lot of sense now that we look at it from beach management and public health standpoints? No, it doesn't make any sense. But it does if you're the public works person and you need to get rid of a lot of stormwater and all your impervious surface. So this is Thompson's West End, as Kim mentioned. It's a nice looking beach. This jetty is gone now. It looks pretty nice. It's not, nothing that really pokes out at you when you look at this. No dogs allowed, but you see dogs all the time on the beach. This gives you a picture. This is Shaquamanon Bay. But then if you take a look at this picture, one of the things you'll notice along here is that that beach is pretty low. And so what that does is it allows for capillary action, water moving from the groundwater up toward the surface, and it makes a very wet beach. So as seagulls, other avian species, your dog, beaver, whatever animal happens to be present, and deposits its fecal material, it allows that material to survive for longer periods of time on the beach, and as wave action hits it and moves it, it goes in and out of the water and then contributes to the overall detriment of the water quality. The other myth, I always tell students that there's some things that you learn from my class, because most of the time everyone tunes out. I can see that right now. It's got the deer in headlights thing going on. But everybody always thinks it's everyone else's fault, right? So Milwaukee blamed Chicago, Racine was blaming Milwaukee, Door County was blaming Marinette, Michigan, or Menominee, Michigan. That was Michigan's fault. No, I'm just kidding. But it's in almost all cases, again, we've done this, as Kim said, at 70 some odd beaches. We have not found one case where there's material moving from outside the sort of beach proper or the area close to the beach in. It's just too much water. I mean, the old adage in the 70s was the solution to pollution is dilution, right? We don't abide by that, but it is true. There's just so much water and dilution effect. And so what does that mean? That means, well, the good news is that we have some control over it. The bad news is we have to do something in our own backyard, and it's not somebody else's fault. It's our own doing. So in this particular location, this wet beach, we realized that harbors bacteria that's contributing to the bacteria that go in and out of the water. What else might be causing it? There are periodic times where this beach, for no apparent reason, would just have extremely high levels. Even out in the bay, we would be out on the sheriff's boat taking samples and looking. Nobody had any rhyme or reason what could be happening. We did a lot of the spatial sampling. Again, this is not the scale, but as was pointed out, we looked to the left, to the right of the beach. We looked out, shallow, it's deep, and that's a really big issue. Again, in most cases, you will notice that the higher levels of bacteria are at the lower or shallower levels. So if you want to keep your beach open, you just go sample at a deeper level, and you'll probably have a lower result. It's true. Anyway, so we identified some pipes. If you look at the average, here's the averages we found. Is E. coli and 100 mils, E. coli MPN per 100 mils. So nothing remarkably high, I mean, not really low. But then if you start looking at pipe discharge, we've got 826, 1,300. That's no good. And we've got our beach right here, those pictures I just showed you, and our pipes located here. There's a small marina and dock. This is an RV park. Then we look a little bit farther. So here's our RV park again. A little bit farther, here's our wastewater treatment plant. And then here's Thompson's Creek again. A little bit of E. coli coming out of there because everybody said it's got to be the wastewater treatment plant. It's the wastewater treatment plant. But really, we don't see that. And so in this particular case, we saw some elevated numbers, but it's hard to say what caused it. We had another group partnering with USGS, wanted to look at this creek. And, you can see increases in dilution effects, and all of a sudden you've got some stormwater input. It rises up again, and then as it heads toward the beach, it comes back down. And so this is sort of the watershed we wanted to deal with because we were able to identify several sorts of input. And if you look at this, is the picture I meant to show, here's our beach down here again. We have this drainage basin right by the park, but then we have this big uphill area, and all the stormwater from this entire area of the city basically flows down this way And then at the time, it was heading right down this road, right next to the road to these two pipes. And so you can imagine that's a large area of water to bring to your beach area. And so as it went by, it would pick up different constituents. And there's a couple artesian wells. One interesting fact of some of the Lake Superior beaches are there's artesian wells that flow all the time. I had a student call me up and say, I found the problem. There's a pipe leaking water. I said, well, really? Wow, that's interesting. Take a sample. They did, and they said, oh, there's nothing there. And then I said, well, that can't be. Take another one. Oh, there's nothing there. I'm like, huh, what do you think? They started asking, and somebody came filling up their jugs of water. And well, lesson learned, right? But the water flows, and what that does is it does push material out of ditches and catch basins and things because there's that constant flow of water. So this was sort of identified in Washburn as different phases of the project, and this was clearly the phase one, or the biggest issue to deal with. And here's phase two, and I'll explain why we did this in phasing. Most municipalities are not able to take, at least the ones that we work with, are not able to phase things in completely if the cost is, say, $200,000. They may say, well, gee, we'd really like to do this. As I mentioned before, the sand in Wisconsin, one of our first locations where we did beach nourishment. In some states, like Michigan, I think they've been doing that for a long time. That was really a big no-no in Wisconsin, and it took a long time for us, again, to educate our Department of Natural Resources that this was really for public health benefit and for the public good. And so with conditions, they've allowed us to do that. What does that mean? Everybody thinks a nice dry beach with a bunch of sand is really pretty, and so people will say, yeah, they go back to that cost sheet. Well, we can only afford all the sand. So that's what we just want to do, the sand and make it look pretty. No, you can't do that because that's not that's not solving the problem. And so what we want to do is develop phasing that accomplishes the goal of mitigating the sources to the lake, and then simultaneously allows the beach to really complete all the phases. So phase one was dealing with all the stormwater, and the way we wanted to do that was develop, this is a copy of an engineering plan for this beach, and this shows sort of the beach water here with elevations. Here's the lake again, here's where those pipes were. And so what we would be doing is basically capping this pipe, running some amount of overland water into a rain garden infiltration bed, and it looks something like this. So it comes down, enters the rain garden, and there's some infiltration, and I'll show you a better example of how this works in a minute. And then water infiltrates horizontally and back into the water, sort of analogous to how a septic system works. The other water that's coming from this ginormous watershed then, much of it then is diverted away and then run through an area again here where it can do infiltration naturally, and then come out in an existing storm drain, water outfall away from the beach area. The water is going to go somewhere. We want to treat it the best we can, but we want to separate it from people to the extent we can. This is another picture of sort of phase one. So here's our infiltration trench. I'll show you a picture of that in a second. So we're taking all this water that comes from that whole part of the town. It infiltrates across horizontally in this trench. There's not a lot of treatment. It's just movement, but it is exposed to sunlight, and so we get a lot of microbial killing from UV effects. This water is then taken again away from the beach out to this storm drain. So it comes to all of this now. All of this area infiltrates here and comes out. So instead of going to the beach area, it's now moving to the side of the beach. Any of the water coming down the road would be diverted into this sort of lowland, wetland type of area where natural filtration will occur. There's a small infiltration bed that's also here. So anything that comes now overland past that diversion trench, if you will, gets treated in some way and then enters the beach water after that treatment. Phase two would be dealing with the beach proper itself. So how do we deal with that beach sand, the low profile of the beach, the wet, really what I'd call microbial fostering environment. And so that would be phase two, which would include nourishment, dune grass planting, and that's one of the other things that we ran into in terms of the education piece. At most of our locations, we plant, or at all of them, I think, we plant dune grass. And the reason for the dune grass is to retain the sand that we're putting there and also catch sand. Anybody seen a beach where they put snow fencing or something up in the wintertime because they want to catch sand? That works, but Mother Nature's been doing it for millions of years naturally with dune grass. And people say, oh, dune grass, and they think of like Sleeping Bear Dunes or these huge dunes. No, sometimes they're just little moguls, and they're really small little features and they really work as great sand catches. And so now we've seen over the past few years that where this has been planted, takes a couple years to fully establish, and then it really is aesthetically, looks nice. It looks like it's been there a long time, and it acts naturally to collect sand on the beach, and so the municipalities don't need to bring it in. This is that diversion trench again, just showing sort of bringing it from this side all the way sort of away from the beach. This is that road. So the diversion trench goes here. Normally all the water would have just flowed here along the side of the road and then right into the beach. This is a picture of sort of how these infiltration beds or rain gardens work. Rain garden and an infiltration system are sometimes a little different depending on how they're engineered. But again, we've got some sort of depressed area. We've got some sort of biofilter mix or some sort of soil that's got the appropriate characteristics to separate microbes and particulate matter from the water, and then things will flow through. And so with this, the phase mitigation, we did the design and the plans through GLRI. So that was, again, a great way for us to do this. We then came with a bid-ready document that the city went out for bids. We did phase 1 with GLRI funding. We didn't have enough to do the whole beach, so we went to coastal management. They funded phase 2. And so they were able to bring funding in to match. One thing we're good at a university is beg, borrowing, and stealing. Well, we don't steal. I didn't say that. Never mind. But one of the things that you have to do is be creative. And I'll use the example of that stormwater pipe. So how do you get rid of a stormwater pipe? The water has to go somewhere. One municipality went to a homeowner and they said, you know, your house is right here. We noticed you've got a permit for a dock. How would you like us to build you a nice, big, long dock out into the lake? Sure, there's no free lunch, right? So what the deal was is they would take the stormwater and they would divert it and install him a dock, and it would go out into the Sturgeon Bay Canal, and they would put the pipe under the dock. And so there would be no swimming, no human contact, but they would be able to remove a tremendous amount of water that would be normally going to that beach. And so I think there's a number of ways to be very creative when you try to solve some of these problems. And then the third part of this, the nourishment, because coastal management, because of their funding guidelines, can't buy sand. So then GLRI was able to fund the nourishment piece, which was really the last piece of the puzzle at that particular location. And they literally are just done about a week ago. So again, diverting stormwater, treatment for stormwater, buffers, and I want to say, just remember, we talk in terms of beach water quality in terms of E. coli or enterococci or some sort of microbial fecal indicator, but really the key message there is it's an indicator. Those organisms that you test for are not going to make you sick. So the E. coli you test in the test, by and large, there's only a few species that cause illness, but it indicates the presence of other things, and that can include chemicals, it can include particulates, other microbial, either bacterial or viral pathogens, and all of those things need to be removed through this process to improve water quality. And the goal for us at the start of all these projects, as Kim mentioned, was source identification and mitigation. And so that was the sole purpose of this for public health protection. And I'm going to show you with the next example what some of the side effects of that are. So another example of this, well, before I do that, we also ran into a couple issues. So what are some of the problems? The first one was poor construction. So we had contractors that would show up and say, I know better than somebody else. And I'll show you an example in a minute. We don't need to do that. I don't know why they put that on the plan. Engineers are just too complicated. And then what they found out is all of a sudden the beach would wash out. Oh, I guess those rocks are there for a reason. Or the other one where we had to do archaeological investigations, like in a parking lot. We're like, this has been a parking lot since 1934, and we had, oh, well, it's never been done. And so you do those things because you have to, and then there's no end to the amount of permitting depending on what you're adjacent to, whether it's state, municipal, Army Corps of Engineers, and there's all sorts of that layers. So you can't just come with the bid-ready documents and say, let's get moving, we've got tons of money. There's oftentimes comment periods and months and months of input, shall I say, before it gets done. There's one beach that had a plan developed in 2007. The design's done, it was bid ready, went to town, and the town's got plenty of money. They could do anything they wanted to do. They've still not done that plan because the town board could not agree to remove one parking spot from 6 parking spots in front of the beach, even though I can walk from here to the end of the building and there's plenty of municipal parking. And so that was just a local politics type of decision, and that beach is still not done in one of the most populated tourist towns in Door County. Anyway, this is one of the beaches. I think Holly showed a picture of this earlier. So this is Egg Harbor Beach, and we like to show this a lot because it's the first one that was done. And now, as I mentioned, hopefully over the next few years, we'll have a lot of examples that'll show the same stepwise that have reached sort of the maturity level. And I'll show you, this one's almost over mature now, and we're running into actually a little bit of a problem. And so this is what the beach looked like before. Vegetation, low beach. This jetty that nobody really seemed to understand what it was there for, and it was a physical hazard for children. We see it as a goose magnet, right? Here's what the beach looked like. This would be a typical day. You'd have 4 or 5 beach goers. You'd have a small little beach area there. You've got some hard infrastructure here, a lot of grass, as Shannon said, pavement right onto the grass. And the slope here, it must drop 75 feet in 100 yards. It's a very, very steep incline, so all the water that when it rains from that municipality goes right down to the beach into the harbor. And so the rock jetty had to go, and so it was just physically removed, and no more rock jetty, and that was the start of it. Then a lot of this hard infrastructure needed to disappear. It was put in back in the 50s, 40s. Whether it was CCC or after that, people thought that that was the way the shoreline should be enjoyed at that period of time. Now we understand that that doesn't do much for us in terms of sustainability of that beach environment. And so all of this was removed. And one of the things we wanted to do is be able to treat that water instead of just letting it run into the lake. And so infiltration beds were designed. So water would come down this hill, hit the infiltration bed, which is what these dugouts are, and it would hit this, and it would infiltrate vertically, and then infiltrate horizontally and enter the beach water at a point where it had already been treated without any of the particulates and microbial contaminants, chemical contaminants that we would not want in our beach water. So this is what it looks like when it started. This is what it looks like when it was done. This was the beach prior to that remediation. This is it right before the planting started. Again, here's our parking lot, and this is all that beach nourishment that was done right here. And again, here's a sort of elevation of that. And so here's where the existing beach was. You can see the retaining wall, and it was a low, flat beach. Now we've nourished it, so we've got a higher, drier beach that's less conducive to microbial growth. Keep an eye on this current water level, 20-year high water level, because what's the difference between 2009 and today? So that was something we had to account for in the design to the best we could. And so this is, again, a picture of it. Here's the initial plantings. As Shannon said, a lot of this, you think it's just a landscaper going nuts, but there's really a lot of thought in this. Geese need that line of sight. They will not, because of predation, they will not go places that they cannot see ahead. So just by making a winding boardwalk, for example, or cord walk through some vegetation will allow them to not want to be there. And this beach is pretty much devoid of waterfowl at this point. There's several other examples of the same sort of principles where we've been able to separate waterfowl from beach water. So the plantings, this is again infiltration. Then we had our dune grass that was planted. This is the rocks that the contractor decided he didn't want to put there the first time. And then just washed the whole beach out, and then he came back and whoops, okay, we'll put the rocks in. Because the water came down with such velocity, he had to slow it down to go into the infiltration beds. And this is what it looked like when it was planted. The town wanted a picnic area. Sorry, this is a little blurry. So we do have a little picnic area, but notice it's sort of surrounded by vegetation, and there's just some walkways to get to it. So you have a place to sit, but you're also not allowing geese or other waterfowl to congregate in that area. Dune grass, this is a little bit more mature. Here's our infiltration swale, porous pavement right here. This is what the cord walks look like. And this is what the beach looks like when it was done. So significant difference from the original beach. And there's a lot of great feedback. So, best towns in America, not just because of the beach, but I mean, you see the new beach being mentioned all the time. Here's some more people that have commented on it. Top 10 destination vacations, so like Kim did. Here's the thing in Wisconsin. And this is what it looks like today. So remember, this was a year ago. I'll show you a picture of today, but it looks very similar. So it went from 2 or 3 people, maybe 8, 10 people on a really busy day, to literally over 200 people a day from 11 a.m. to 6 p.m. And this is a town of 200 people. So you can imagine the impact that those 200 people have staying in that town the whole day. They now have kayak rentals. You can see things down at the end here. You see people bringing their boats in and they park outside the beach. They'll come to town. So it's extreme. It's almost too used. And so what we find too is people, because of this, it's more aesthetically pleasing. And so people make decisions on which beach. There's 27 beaches in this county within 20 minutes of each other. So if I'm taking my family to the beach, now I can make a choice. They're all equidistant basically. And so I pick and choose which beach I want to bring my children to because it looks better and it's a great place to be. So not only have we solved the water quality problem, public health protection, but we've now created a beach that's more aesthetically pleasing and is an actual economic driver for those municipalities. And so all the other beaches after this was done started getting done through that county. And then as Kim said, this has been happening in Manitowoc and Thompson's West End, Broad Street in Bayfield, so all over the Great Lakes. And this is really a side effect we hadn't considered at the beginning. Here's our new challenge. So high water comes up. This is our beach again, and we had one big storm. The one thing that is operation and maintenance with these beaches is when you nourish, you will have to put some of that sand back. There's a 5-year plan. This beach didn't have to do anything for 5 years, 6 years, and so that was great. But we did have one big storm early this year that did remove a bunch of the top sand on the beach. And so you still see the chairs there that you saw in the other one. It's still more heavily used at the time of this picture. It's been sort of fixed now. But you're subject to any of those things. However, the dune grass plantings and other things you put at the beach help retain all that sand. Without that, a significant portion of that material would have been gone that is not gone today. This is a different beach. This is in Marinette. It's sort of, I call it the cord walk to nowhere because the water came up, and so a lot of the beach sand that was right in front of it is gone. So what's happened is the beach now has sort of naturally moved up. The cord walk's been shortened, and so you still have access to the beach, and the principles of all this infiltration from the parking lot are still in place. And the beaches are still bigger than they were before, even with the elevated water, because the beach slope is much smaller, or the swash zone is much smaller than it was before. So as I sort of leave you with this, this is a great comment where they're comparing the beaches to Cape Cod, and I can't emphasize enough that in today's political climate, certainly in Wisconsin, everything's economics, and I think beaches are one of those things that we have an opportunity to really marry several things. One is environmental, public health benefit, social equity. Anybody, you don't need to pay for a wristband, you don't need to pay for a hotel room at this place or anywhere else. Any person, regardless of their socioeconomic status, can use a public beach. So it is something publicly available to anybody in your state. And the third piece is it can be an economic driver for communities on the water. So the Brookings Institute determined that a $26 billion investment in the Great Lakes will yield over $80 billion in return. And so we've found that these economic benefits, we have 15,000 lakes in Wisconsin, and there's counties that if you have poor water quality, all of the economy goes down. In the waterborne outbreak that happened in Door County, we got the call and they said, the concession stand at the beach is losing $10,000 a day. And I thought, how many t-shirts and hot dogs is $10,000? But they rent kayaks and they do all sorts of stuff, and that's how they make their livelihood in 3 or 4 months out of the year. So they were literally losing that kind of money. And so if you look at the benefits, each beach user, I'm just using Wisconsin numbers, spends somewhere between $45 and $60 a day when they go to the beach in these towns, whether it's gas, supplies, materials, buy lunch, dinner, whatever it happens to be. And so in Wisconsin, we have a $13 billion tourist industry. 5 to 6 billion of that is tied to water, and that's not even including the property value issues for people that utilize the sort of same techniques that we're using for private shorelines. And so we see increased visitors, restaurants, hotels, small businesses, all the tourist attractions that go with that. All those people are going somewhere and they're making conscious choices, and now beaches are part of that decision-making process for them. It used to be, well, I just like the restaurant in that town. No, now I'm taking Susie and Mikey down to beach ABC. And there's many more examples. Anklam and Bailey's Harbor is another one. There was almost nobody that used that beach. This summer I went there 10 times and there was never less than 50 people there at any particular time. So really important principle. So you go from this to that. And some could argue that there's days that you might not find room for your beach blanket. But with that, I'll take any questions. I think we have a couple minutes, and so thank you.
Can you please repeat your question?
I'm sorry, ma'am, I can't take a question from you. I'm just kidding. Well, go, Christine. No, you.
Okay. Did you run into any roadblocks with working with your municipalities for maintenance on those beaches?
Yeah, so that the question is, did we run into any roadblocks with maintenance? And yes and no. We had to do some education. Of course, everybody is stretched. Everyone's doing a job and a half, or 150% effort. And so one of the things that we, as I mentioned, tried to do is inform them that this is really in their best interest, and it's really going to be low maintenance. They're not going to have to do a lot, maybe clean some catch basins. One thing I didn't mention, with all of these plans, there's a best management practice document or guides that go with each of these. So cleaning catch basins, beach grooming, and so there was a little bit, but again, they realized that this is in the best interest of their communities, and in most cases it was done right. We did catch a person with his four-wheeler and towing his bed springs as his beach groomer. So we talked to him about that, but a little bit, but not tremendous. I mean, because it was really sort of handed down. Maybe if I was in the municipal garage when they were leaving to go do the work, it probably would have been a different story. But
We've got some webinar questions. I'm going to bring this. How do I read and talk? Just talk really loud? Yeah. Okay. Or can we take this over here so we can?
I'll just draw it right here.
Or can we read them over there? Okay.
And every time you deal with fecal material, you have to have a sense of humor. So I made a mistake one time of telling people that you couldn't find E. coli in beaver feces. And then the people at the state lab in Madison started sending me Baby Ruths in the mail. I'd get my office, I'd get little baggies with Baby Ruths. And then all the sewage haulers all have those great logos on there, like I'm number one in the number two business. My favorite one is stay back 400 feet. This truck's filled with campaign promises.
All right. So here's our first question. Are the people collecting water samples for monitoring also? Sorry. For people on the webinar, sorry. Okay. Are the people collecting water samples for monitoring also collecting the routine sanitary survey information? Are there concerns about this taking too long since the samplers have time restraints to get samples to the lab? Do they take photos too?
Do I have to use this one too? Oh, so the question is are the same samplers collecting routine monitoring samples, sanitary survey data, and do we have problems getting samples to the lab? Yes, and no. No, I'm just kidding. It's the same group. For efficiency's sake, yeah, the routine samplers, we have a group that does this at each location. They're housed in these counties. They live there. They are part of the community. They leave some days at 6 a.m. They'll collect the samples. They collect routine monitoring data, and that's brought back to our lab. We happen to operate the lab in the community, and then they do that analysis, but then they also do the routine and annual sanitary survey data collection, any extra things that might need to be done. We do try to take pictures. At the beginning, we were really good at pictures. Now we're getting a little better. It's usually the lowest priority, but it is, time is always a challenge.
All right, here's another question. What is the criteria to determine if a beach is impaired?
So the question is, what's the criteria for determining if a beach is impaired? I will say that in our particular case, I'll pick on Door County because we have the most amount of data for that county. It's less than 5%. Wisconsin's unusual. We have a two-tiered advisory system. So we have an advisory at a beach, and then we have a closure level. And so less than 5%, it's about 4% of the beach samples result in an advisory, and it's like 0.5% result in a closure. So the levels are fairly low. But the philosophy at any of these beaches are that any amount of contamination into the water is too much. So each municipality has a different level of threshold for impaired. We have another municipality not too far down the Lake Michigan shoreline where each beach is closed about 40% of the time. So it's a significant difference. And so clearly there's some impairment in that beach.
All right. And then there's just a simple question. What is the difference between beach redesign and beach mitigation?
Difference between beach redesign and mitigation. So I would say the redesign is the process that mitigates whatever the pollution source is at the beach. I think in some ways that's semantics. We call it beach redesign, beach reengineering, beach mitigation. It's the same process.
I'm curious about the timing between samplers having to be out there in the early morning, and I never go to the beach at 7 a.m.
Yep.
So what, how do you know the bather load?
Yeah, so that's a good question. So at any of these points in time, it's like taking a photograph, right? You have no idea what happened 5 minutes before you left. And when the students leave or our samplers leave at 6 a.m., we have islands we have to sample, so it might take them 2 hours to get to the beach. But there is no doubt that they're at beaches at 8 in the morning, at 9 in the morning, when it's not peak. What we've found over the years, even though Wisconsin's the home of the little swimmer, what a terrible thing for the beach, right? Your kid never has to go to the bathroom and sit at the beach all day long. But what we found is bather load contributes some amount to the microbial load at the beach, but it's not the primary driver. What we want to do for the sanitary survey data, we will go back at times with peak load, or especially if we want to get bather numbers or things on, for example, if there's a lot of people at the beach late in the day, there's never any waterfowl. However, some beaches that haven't been redesigned will have tremendous amounts of waterfowl in the morning, or algae, for example, and that washes up on shore, some waves come and take it away, and then all of a sudden a bunch of bathers come, the algae's gone, the gulls are gone, but there's this whole like primordial ooze of microbial goodness that they're swimming in. And so those are the types of things we try to do the best we can of matching them up. It is difficult sometimes to sample like at 1 o'clock in the afternoon at all the locations, but the samples occur generally from 8 to maybe 2 o'clock, and so most of the locations are getting sampled with a pretty significant amount of use. We do. The question is, do we work with private homeowners and not just municipalities? And the answer is yes. We work with a number of homeowners or lakeshore associations, offer them advice. There are some limitations on what in Wisconsin our Department of Natural Resources will let homeowners do on their beach relative to what they'll let public entities do. And so there are some differences, but we certainly offer any advice. We're willing to pass that on to anybody. People can just call us up. I mean, I think Kim or I will have some cards or contact, or you can Google us and feel free to email us. Yeah.
Any other questions?
I can't tell you how many people, if you do this in your community, how many retirees, people that have been in those communities for a long time will come up to you and say, "I can't believe you guys did this. This is what it used to look like when I was a kid, and I remember all these people using it." And those are really, I mean, long before my time, even though I look old. And it's really nice to hear the community say that, because I think there is this hump to get over. But there is this group of people that remember sort of the way that these locations were many, many years ago. And so it's always great to get that feedback. Usually it's people complaining. So thank you.
All right. Well, thank you. All right, we're going to take, do we have at least we're going to take at least 5 minutes break. And for the webinar audience, we're going to put the phone on mute, or the microphone on mute, and we're going to put the camera outside so you can see our view. It's beautiful up here. We got peak colors. So for the rest of you, go ahead and take a 5-minute break, and we're going to load up the next presentation and get started. Audience queued up. And our next session, so you're probably a little fatigued by presentations and PowerPoints. So we're going to give you a break. There's really no more PowerPoints. This is our discussion time. So here's QPCR Shop Talk. Hey, Michelle's here. And is Deb here? Is Deb from Standish Township here? Okay, she's going to come in this afternoon. I think so. Last time I talked to her. So what we're going to do today, just to give you why is Michigan all excited about QPCR, and it's because we just launched 10 new labs. So Michigan has 10 new labs that are running QPCR, and a lot of those staff are here. So trust me that I do not know as much about QPCR as many of you, and especially Michigan State University. So the DEQ is partnered with Michigan State University with Dr. Aaron Dreeland, Dr. Tiong Ah from Singapore, and with Joan Rose, who's in Cambodia or Singapore or somewhere between. And they have been helping us provide training in the videos, and help troubleshoot. So for some of you, if you would like to be a part of this, we have this thing called My QPCR. You can talk about it. It's a listserv, and it's for us to talk about why are my results coming back fuzzy, why my results make no sense. And it's a QPCR listserv, so we can talk to each other. So what I'm going to do right now is turn this over to Aaron, and we're going to run this microphone back and forth. It's designed for you to ask questions and for us to help answer those questions collectively. Does that make sense? All right, and if our webinar audience is ready, they can ask questions, and we'll just get them to Aaron too. Okay, so here's Aaron.
Morning, everyone. As Shannon mentioned, I guess we're just going to look at this one slide. Well, we promised no presentations. Right? There we go. So our goal for this session is to provide a discussion forum for all of those who are using QPCR for recreational beaches, or even if you're interested. So, again, okay. So our first step, though, is to figure out actually who's in the room and who is using PCR. So I know you just sat down, but I am going to ask you to please stand back up again if you use QPCR. A very good group. Stay up, don't sit yet, Because one of the things that we want you to be able to do is to network with one another, so you can make a note of who the people who are standing up are, so you can connect with them during this session and over the course of the next couple of days. Okay. So we also want to figure out how much experience do you have. So what we are going to do, all of you are standing, and I'm going to seat you by how much experience you have. Okay. So if you are new and you've only been using QPCR for a year or less, you can have a seat. We lost everybody. So we have a lot of people who are new to QPCR in the room. That is great. It's wonderful. What about those of you who have been using it for a couple of years? So you have some experience, some more, and Rich and Tian. Okay, so then 4 to 5 years, probably. So what about Rich and Tian, our most experienced QPCR folks? How long have you been using the method?
Probably about 20 years. 15 years.
15 years or so for Rich. Tian?
This is my first year of my first year.
About 8 years for Tian. Okay, so we do have experience in the room. Okay, so what we'd like to do is to start off with getting you thinking about questions that you have about QPCR and using it at your beaches. So for those of you who are new, sounds like most of you, I'd like you to start thinking about what's giving you headaches about this method and where are questions coming up. For those of you who are experienced, whether you've been doing the method for just a couple of years or 15, I'd like for you to think about what advice you would give to people who are just starting out. Is there something that you would think of, oh, I wish someone had told me? So I'm going to give you time at your tables to think about these questions. And if other questions come up, feel free. As Shannon mentioned, the session is really driven by your questions and your needs. But we'll just kick off with these two. So I'll give you a couple of minutes to brainstorm at your tables, and then we'll come back as a group and hear some of those questions.
In the webinar.
Yes. And yes, for those on the webinar, please send your questions as well. Okay, so I'll give you a few minutes to think about that.
What would be your advice?
It's a whole new thing to me, and essentially, I got married in April, and Michelle says, "Hey, you're doing this stuff this summer."
Yeah.
Okay, what we'd like to do now is hear some of the questions, and we're going to draw upon that experience that we have in the room to hopefully also get you some answers. Okay? So we have questions from our webinar audience, and we also have questions from each table, and we will take turns going around the room. So shall we have a webinar question?
Yep, no. Okay, so the first question from the webinar group is, how do we sign up for the QPCR listserv? It sounds awesome.
It is awesome. Send me an email. So my email is just my last name, so it's Dreelin, DREELIN @nsu.edu, and I will sign you up for that listserv. How about questions from the room? We can come back. So how about this table? Do you have a question, or was a theme that came up about using QPCR?
Well, we're just getting off the ground, so we're still, just finally got all their equipment in, and so we're just basically at the training and play stage is what we talk about is the differences in what you're doing in Illinois and Michigan, and how we're hopeful that we can get some real-time samples even now to play with, to freeze and play with throughout the winter, just so we get some under our belt before we start in the spring. And we're still doing the curves and everything.
I'm not sure it's going
Oh, that's right.
Okay. For those of you who couldn't hear, they're talking about, this is a new to QPCR table, and so they're just starting out. So again, can we have a show of hands of the people who are just starting out? Right, great. And so one of the topics of conversation that came up is going out and collecting samples even right now, just to be able to work with the equipment and learn the method. And
Filter and freeze.
yes, filter and freeze, and then move on. Okay, other questions that came up, and we can move around the room, or if you'd like to share yeah, a great idea. So if you can come up, we can give you the microphone. Unfortunately, it is wired. I can't bring it to you. So if you can come up, or if you want to speak very loudly, we'll repeat the question for our online audience. So questions?
I'm new to the QPCR also, and it seemed like when we got a lot of material, the method itself seems cut and dry, but it's all the prep work to get to running the method is what I'm having large major issues with. Setting up my salmon term and making sure I have the right solutions and just that initial setup. How do you make this? Well, this is in chapter 4 of this, and so it's just kind of trying to piece everything together to just get started is where I'm. Yeah, kind of thing.
We second that.
Others second that?
Can you repeat it?
Yes, so that, and I saw hands in the back, so I think you heard sort of the frustration of just getting all of the prep work done so you can actually start doing the method. I wonder if we can get some comments about that from Rich and Tian, our experience. You're going to have to come over here and use the mic.
Actually, when we send out the labs, the crab, we actually simplify the method. But I mean, I would like to hear from all the new labs if you think that there's something we can improve in terms of the crab, and how can we improve that? How can we simplify that so to make it more easy to understand? And we are happy to do that.
So trust me, I'm the one that wrote those quality assurance project plans. Oh, they're joyous. And then poor Dennis had to read them. He's the one that, so if you wondered who is Dennis Bush, who had to sign off on those QAPs, he's right here. And he does read them page over page. So when we have those QAPs, would it make sense that, so method C is what we're talking about for the webline, online people. So with method C, you're saying that the stepwise directions are all in there, but they're kind of sporadic.
Yeah.
Would it make sense that we would kind of do a front-end primer that says, here's how you make your, because is that in the training manual?
Yep, there's some cheat sheets.
Oh, sorry, gotta use that.
Yes, there are some cheat sheets in terms of, okay, let's go through a checklist and make sure we have done all of these steps so we're actually ready to go. So you're not flipping back and forth through the manual. But we can make sure that those are easier to find.
I guess I'm just used to working like a SOP. Do this first, do this next, put this amount in, I work in analytical and microbiological, mostly analytical, so I'm just so used to just like reading and it telling me exactly what to do, step by step by step by step.
Right. Not flip to chapter 4 and then make this.
Yep.
Okay, a very good point. We will review and revise and make sure that we're getting that up and easy to access. And we can also send that out through the MyQPCR lister if folks think that will be helpful. I see nodding heads, yes. Okay.
One thing I had to add to, use the microphone. Don't pull it out though.
Yeah.
If it would be possible to maybe break some of the more scientific terminology down for the local health departments who have not had any lab training. I know that would be helpful, especially for me, step by step, how do I measure glass beads out? What, do I use a teaspoon, a piece of paper, that kind of thing? Just more break it down in layman's terms. Tips, yeah.
Okay, great. I did see hands in the back. Was there another question?
With Barb and Cheryl at your table, did you guys have questions? I know you guys are talking. Did you have some questions or? Can you come up here though? Can you come up here for the microphone? Can you hear?
Where are we starting? The same people are looking at with other applications that we are. We have to start from a 8.5 solution. Are we making it 1 to 10 of that, or 1 where are we starting? One of our other analyses that we use solution. Yes, we can find it before. This that us, and I was just asking my friend Rob the other day, when we're with our finances, these are my creditors, well, how long for that needs to spell out for us because we use the bank. I would like to know that in the end, when I got the results that I did, I don't know what should we do. All of this really needs to spell out what workshop, standard operating procedures. Also, I was giving you a colleague before, she had focused this target that we were looking for that pushes a user country. And I said, well, we use 300. But when I was speaking with her, she said, well, after 5 or 6 people, the number we look at might be up 330. Well, I'd like to know where should we go and what should be our minimum level? Where should we put to be our target?
Would you like to fill the what should be our targets?
Can you guys summarize? Because nobody could hear.
Okay, there were 2 questions in there. The first was about hosting a workshop, a wet workshop. So I see nodding heads around the room. Could I get a quick show of hands in terms of interest in coming and attending one of those workshops? Okay, yes. Okay. because this is something that we can arrange at MSU and in our lab. So we can work on that. And I imagine going into the winter might be a good time for you to have time to come over to East Lansing. Okay, great. Another good suggestion. And then more discussion of having those clearly spelled out steps and standard operating procedures. So that is something that we can definitely work on. I'm going to hand the microphone to Tian because the second question was about standard curves and what those should look like and what we should be aiming for in terms of targets.
And I can explain our rules.
Okay.
I mean, the standard curve, for our lab, we usually go from, I mean, to have at least 6 or 4 to 5 standard points from 10 copies all the way up to 10 to the power 6. Sometimes we try to do below 10 copies, but it depends on the technician. Sometimes you can get the detection limit down to 1 copy. Sometimes it's hard. So, yeah. And if you want, and for the standard curve, we actually have a criteria for a good standard curve. If you refer to the CRAB, the SOP, there's 3 important criteria. One is the slope of the curve, and then the R-square of your standard curve, and also the y-intercept cutting point. So.
Yeah, and I'll explain this.
Right, and Shannon is going to talk about the standards.
Right. So most of us are from Michigan, and so we picked our own numbers. The EPA number, the national number for E. coli is 235. So single sample, 235. Don't even get me started on beach action values. That's a whole other, we'll have beer for that discussion. And so for 235 is what a lot of people use, but in Michigan, we use 300 E. coli per 100 milliliters. Now that's just on a daily sample. So let's say you're taking your water samples, they come in by the day, and you're trying to get the target. With CoAlert, the numbers are 300 in Michigan, or in Chicago, 235, or Ohio. But let's say you've been doing this for a month, and now you've got at least 5 samples, they've all come in. Now you can start calculating a geometric mean. Now the geometric mean for the national number for like Ohio, Chicago, for E. coli is 126. In Michigan, we didn't like that number, so we made it 130. So those are the numbers that people are talking about. Is it 235? Is it 126? I don't know. Well, it depends on how many samples you have.
Sample events.
Sample events, exactly. Because you need at least different days. You need at least 5 days of different samples coming in. And then you can start calculating that rolling geometric mean. That's kind of good to have a 30-day geometric mean if you're in a long-term monitoring program. But as a swimmer, do I really care what the last 30 days E. coli were? I don't care. I want to know right now, can I go swimming right now? And so unfortunately in our rules, this has been the 30-day geometric mean, has been a sore spot. Because today's water samples are less than 300, but our rolling geometric mean over the last 30 days is still over 130. So should I be afraid of what the water was 10 days ago when the water's good now? So this whole idea of using QPCR and using rapid and virtual beach and getting today's number right means I care less about the 30-day geometric mean. Does that make sense? So my first priority is what are the numbers today that make sense today? But on a long-term monitoring program, then I will kind of pay attention to those 30-day rolling geometric means. And there's other things that you can use as well. It's called a percentile, like the 95th percentile. You can use that instead of a rolling geometric mean. And then the percentile at the end of the season helps you gauge where was your beach. Was it low most of the time, or did it go really high? And so hopefully that explains why these standards are different. And I know maybe you guys want to talk about this. I realize there is a method and a number for QPCR for enterococci, but it doesn't work that way for E. coli. And we're, probably Rich, you're going to talk about that this afternoon quite a bit. You want to come up here, or Kevin, or Rich, or John? Put you guys on the hot seat. The question is, so eventually Michigan and some of these other places, we need to convert what is equivalent in QPCR to the COLALERT results, the culture-based results of 235 or 300. So those are the triggers to open or close beaches. So now that we're going to be running water samples for COLALERT and QPCR, because we don't know what our QPCR results, we don't know what those look like or mean or whatever. So we want to run them against the COLALERT, the culture-based samples. So we'll still be opening and closing our beaches for a little while based on culture methods, but we want to be running the QPCR results on the side to see what they look like. And I know that might be technically, statistically incoherent, but that's the way we're going to do it. I'm sorry, you want to come up here and say that? For the poor webinar people that are, do you have some more webinar questions? Okay. All right, so for the webinar people, we will come back. So John Watson is going to explain where this information is.
Yes, establishing equivalence between methods for determining beach thresholds is something that we have addressed in technical support document, and it is on the website for the recreational water quality criteria. And Rich just told me it is on one of his slides that he's going to show this afternoon, Rich. Right. So you can scribble it down, or you can just, go to the 2012 recreational water quality criteria website at epa.gov, and it's on there. It's a link. So there's a full description of the kind of statistical tools and the approaches to establishing equivalence.
Thank you. We do have a couple of webinar questions.
Sure. The first is kind of long. Regarding PQCR, we sometimes have trouble with getting signal on our non-template control. We filter the water and then extract from the filter for the empty control. We filter water that is micro-free, but as mentioned, still get signal, albeit low. We use the BIIA7 system. Do you understand the question? I'm just trying to read it as I.
You mean that you get a QPCR signal from your filter water sample as a negative control. We usually don't use filter water. You can filter the water, but make sure you autoclave it and UV. So because filtration will not remove the DNA from your water samples.
But you can buy PCR grade water.
Yes, you can buy a PCR grade water. I mean, usually if you buy a PCR reagents master mix, it will come with the PCR grade water. So use that for your negative control.
And a comment from Rich.
This sort of gets to the question that was raised earlier about what the limit of detection of the method is. The method is actually, it's not going to detect one E. coli per sample. So, the way we've approached it is, because we see this from a lot of labs ourselves included, that will get some weak signal from a negative control. We're not concerned about it if it's below our limit of quantification, and that eliminates a lot of problems in that regard. And if you think about it, I think it makes sense because that limit of quantification is well below whatever your criteria are ultimately going to be. So if you've got a little bit of signal, are we really concerned about it?
Another web question.
Okay, one more. What time of day generally does the sample need to be collected in order to ensure that the lab results are obtained in time to notify the public if the beach is open or closed that day?
Anybody from Chicago want to answer that?
Yeah.
Do we have Chicago here?
All right.
Here we go. Can we
Our
hear
winner.
from you, please? So if I heard correctly, you collect at 6:45 or 7 a.m.? Okay, so start collecting at 6:45 or 7, and you're back in the lab at 9, and then posting results by 1 p.m. And I think that was how many beaches are you doing? Okay, so collecting at 5 beaches.
How many samples per beach?
How many samples per beach? 2. Thank you. Other questions? Can you come up, please?
So I'm not a lab person, and all this is way over my head, but
You say you're Adam Mednick.
I'm Adam Mednick. And the question I have is, once people, I guess this is for the experts, once folks are up to speed on using PCR for this rapid detection, how much of a jump is it, sort of technique or methods wise, to use it for source tracking?
We're going to have Rich come back up and comment.
I believe that once you have the method, any QPCR method working well in the laboratory, that it becomes very simple to move to other targets. So basically, all you're doing is changing the timing of the approach.
Do you have suggestions?
Sorry, I'm a little unclear on your elucidating the source tracking comparing your beach water to a possible source, or are you subtyping the DNA in some way, or will you get specific elements in the DNA which are traced back to the species, or what?
Yeah, I mean, typically in a molecular QPCR standpoint, what you're doing is you're targeting a DNA fragment from an organism that's been associated with a specific host animal. So, obviously, human is a biggie there. So assays have been developed that are targeting a gene that's only found in bacteria that are, well, I shouldn't say always, but at least 90, for the most part, are associated just with humans. Does that answer your question?
Can you list off some of the human markers or the other markers?
Yeah, there'll be 2 EPA methods that'll be coming out probably within the next year that'll actually fund through EPA validation. So they'll be, they'll have EPA numbers similar to the Enterococcus. Those are for human, 2 different assays for human markers. One of them is based on the assay that was developed a number of years ago in Kate Field's lab, the HF183, which maybe some people are familiar with that. And another one was developed actually at the EPA. It's called HUMM2. So those 2 assays, like I said, have been validated by the EPA and will be coming out as EPA methods in the near future.
What would be the associated cost with these sources?
It'd be pretty much the same cost as doing the general indicator assays there. Like I said, it's basically just, I mean, those methods, there's a little bit more sample prep involved in it. I think there was a little bit less concern about getting a rapid result with those methods. Because you're sort of using those to characterize, as part of your sanitary survey process there. So there isn't quite as much emphasis on getting a result today for those type of methods. So that, and because these indicators tend to be lower, the general indicators, there's more of a purification step and a concentration step involved, which adds, it actually adds some time and cost to those methods. I guess, I'm backtracking what I said before a little bit, but I think it's, maybe doubling the cost for what it would be for the enterococcus methods with all those additional materials you need for additional purification steps and so forth.
Did you say you needed an additional probe, or did I misunderstand?
Yeah, I mean, every target that you're targeting, basically, that's how you target it, by having it in the primer and probes.
How many different species of the primers and probes do you have? Do you have like humans set already? Do you have bovine and that sort of thing?
Yeah, well, like I said, the EPA has focused, for I think obvious reasons, on human markers as the first step in that process. Actually, a lot of laboratories have developed various assays for dog, deer, cow, pig, so forth, including the EPA. But in terms of validated method, obviously human was considered to be the top priority. And that'll be coming out first.
And our lab actually has using an assay. Our lab is currently using an assay for bovine markers, especially in Michigan. They want to know the contamination is coming from a farm or from the human source. So, and I think in the next few months, we're going to try using pig markers and also poultry markers.
Other questions from the group or from online?
No, we just use a regular pipette tips, a clear
Can you
pipette
repeat the
tip.
question?
Oh, the question I think is pipetting problems. Oh, you cannot see the small volume that flow through. Yeah, I mean, we usually use a clear color pipette tips. Yeah, I believe it's hard to see, especially when you pipette less than 10 microliters. But you just have to believe that you yeah. But I'm not sure about different kinds of pipette tips can help to better see the pipette. I mean, to better see the liquids flowing through the pipette tips. Maybe is there anybody has the experience? I mean, with pipette tips.
Yeah, so for those who didn't hear and for our online audience, the response was what they ended up doing was putting a piece of colored paper behind the pipette so they could see the fluid a bit better.
Does that have a chance of being contamination on purpose? Like DNA? Like,
No, I
introduce DNA in there? Like, would you UV the paper?
Yeah, you can just UV the paper.
Yeah, the question is whether you would potentially introduce some contamination with that piece of paper. The response was, you can UV the paper.
Yeah.
Other questions? I do want to point out that we have Holly and Jim here. So if you have equipment questions, the two of you can stand up. They can handle equipment questions. They will be here today and tomorrow. So there is a table downstairs in the exhibit area where you can talk with them.
Or now, baby.
Yes, or now if you have any questions for them. I have a question in the back. Yes, please.
That's about as far as we can get.
Thanks. I was just wondering if someone could speak to ordering the standards or standard curve development. I see that EPA is offering that now. Sorry, that's not loud. I haven't done that process yet, but obviously I'm very interested in simplifying that. If that's something we could talk about.
Rich, would you like to respond?
Yeah, if you go to the site that John was referring to, and I'll have it up, the link up on my slide this afternoon. If you go to our methods, as far as the EPA standards, there's an appendix in the back there that basically gives you all the information on requesting standards from the EPA. I think they shipped out sort of on a monthly basis there. So, that should give you detailed instructions on how to get the EPA standards, which are right now free. Yeah. I think that, we don't have an unlimited quantity, so I think, I was talking with Kellen about it. One thing that I think it'd be useful for you to do is to sort of use those as a baseline for your generating your own standards there. Again, I'll be getting into this at least in terms of our methods this afternoon. Our approach to this, which is basically you do a number of standard curves at the front of your study. You do enough to get a good composite standard curve. You have enough replicates so that you know that these are good curves, these are outlier curves, and so forth. But then from then on, you really, unless things go south on you, you don't really need to be doing them over and over again. Which is good because standards pulling them in and out of the freezer is a bad thing. You like to get that information up front there. But in our method, again, standards are sort of done up front. The calibrators are done up front, and then from then on, you're just sort of using your calibrator samples, which are just extracts of the cells, as your ongoing QC process.
Other questions from the group? Is Aaron Hogenboom here? Yes.
Aaron, can you come up and explain how you were practicing with the salmon DNA? That was a really good tip, but we're still a lot of newbies here, so I think that might be an interesting exercise.
And for those online and didn't hear, we're going to hear some tips for our new labs. And this might be something that those experienced people in the audience might want to think about. And I kicked this off with what do you wish someone had told you when you started? So you might want to think about that, and we'd like to hear from you.
Well, initially we started using the E. coli DNA provided by MSU to generate standard curves. We were having some issues. We weren't getting curves that fell within the established criteria, so we backed off. And we actually used the salmon DNA instead, using the primers and probes specific to the salmon. And we were doing the same type of thing, doing the dilutions and running the curves with the probes and primers. and all 3 of our staff were able to generate curves within the criteria on multiple days, so it worked very well. Unfortunately, we've gone back to the E. coli DNA and attempted standard curves with those, and again, we're still having problems. So we're kind of in a problem-solving issue right now, trying to figure out exactly where we're going wrong. But using the salmon DNA is it's very easy to use, and it's great practice for your staff. Getting the dilutions, learning how to do the serial dilutions, learning how to pipette all the reagents into the plates, make the master mixes, because you're provided with a large amount of the salmon DNA when you buy it, so there's a lot to work with, as opposed to the E. coli DNA that you get from MSU. There's a very small volume, so you're very limited on how many runs you can do.
Other tips from our experienced QPCR labs? No, I'll let you chew on that a little more. I think we have an online question.
Yeah, we just had somebody ask if we could post the website of tools available by EPA and USGS. Are those going to be posted?
Yes, definitely. We can post those, and again, we can also send those links directly out through the QPCR listserv as well. Other questions? Or advice from our experienced labs? What has worked for you?
All right.
Okay. You'll be next.
Do you mind stepping up a little bit?
Sure. Yeah, well, I think when Aaron posed the original question, I jotted down 2 things there, which we've touched on a little bit already, but I think the first thing is follow the protocol. People, I think people always think they know a little bit better, but I mean, I think, so the comment was made that our protocol is a very long and arduous protocol. Well, there's a reason for that in a sense. I mean, we're trying to cover as much detail, as we can in that protocol. So, I mean, I hear you when you say that you're having to jump back. I don't know if it would be possible for you to sort of, after you read through that, sort of develop your own SOP.
Yep, that's what I'm doing right now.
Yeah, because I mean, I'm sure there's details that we're still missing in that, but I mean, it's, I mean, there's a reason why it's a long protocol. I mean, we're trying to cover as much as we can. And the second comment, which is sort of just follow up to what we were just talking about, we've got to have good standards with these methods there. Everything is going to be based off of those standards. If they're, and in terms of comparability of results, they have to be common standards, or at least you have to document that my standards are the same as your standards. So in terms of comparability of results or comparability to a standard, that's really a critical aspect of these methods.
So I'm Holly Center, and I'm the representative for Life Technologies, where the Step 1 Plus came from. And so I do have one downstairs. I bought a computer with software, but I'll bet most people didn't bring data files other than Excel spreadsheets, which I can look at, and I can give you some general guidelines, but I can't translate into standard curves for you. So one of the things that I think I'm going to offer to everyone here, I know that I've worked with almost every lab to get everybody set up, and we've gone through some trainings, and before you actually do the work, I mean, it's great to look at that, but it doesn't stick until after you start doing stuff, and I totally understand that. And so a couple of things that we can do to help you get back on track is that I'm going to ask Shannon to post my email address on the listserv,
And then if you have a data file that you want to discuss with me, I'm going to have you email it to me, and then I will give you a call, and we can walk them through together over the phone. I won't be able to travel to your sites individually, but I'm happy to walk you through step by step so that you feel comfortable with the setup and looking at the data and how to get the data out so that you can put it into your analysis spreadsheet. Okay? And so that's one thing that we can do. If there are any questions, you want to look at some stuff or you have some simple software applications you want to talk about, I will be downstairs with the computer with the software, and we can definitely go over that with you. But I'm here to support you and help you as much as possible in terms of utilizing the instrumentation and getting the data out of it. So feel free to stop by and see me.
Any other questions or comments? We do have one. So for those on this side of the room and online, the question was what type of data file should you be sending to Holly? And the response was not an Excel file. It's a .eds file that is generated by the Step 1 Plus. Other questions, or I'd like to hear a bit more from our experienced labs, those of you who have been working with QPCR. Again, a little advice for our new labs that are starting out. We had some good advice from Rich. Do we have what you wish you had been told, or something that you have figured out that makes life a little easier as you're working through the method?
I was going to ask you a question.
Okay.
All right, so to try to get away from the technical stuff, to pull your brain out of a knot, how about the beach managers here? How about, do you have any questions? Do you have questions about what you're going to do with the QPCR results? Have you seen any? Does anybody have any questions about what are we going to do with it? How are we going to handle it? Yes.
I am looking for a quick solution to not close the beach 24 hours after the result. That's our main focus, right? I mean, it's ultimately what we do. We go out, we sample the beach, we want real-time data, we want to know right away if the beach is good or bad. So being patient, we are, because our health department does not have a lab. We refer to Experience University for our lab. How soon before we're ready to go? I guess that's my question.
The question is, we have these QPCR results starting to come into your office. When are we going to start using them? That's a great question. How many people in this room are the ones making the decision of the beach is open or closed? All right, there you guys are. This is a public health policy question. So in Michigan, so here's I'm going to go look at the public health code. A health officer is the only one in Michigan that can make a decision whether to open or close the beach because it's a public health decision. That health officer can delegate his authority to sanitarians or other people, and that's the way things are going. It's working out very well. A lot of those decisions are based on our water quality standards, 300 or 235 or whatever it is. However, you can make a decision if you see raw sewage, you can say the beach is closed right now. So what we need to do very carefully is look at those documents that John Wathen explained, the transition documents that help you go from what we're used to the QPCR results. That's where we're headed. That's the next step in all of this. I don't know how long that's going to take. I think it's going to take time to develop to go through the process. And maybe, John, you can tell us how long does it take typically for like somebody like Julie Kinzelman or Ohio, Mark Citriglia. Do you know how long it took them to go through the transition to start using QPCR results to open or close beaches. And can you come up here to explain that?
Probably time to say that I'm sorry that Julie Kinselman isn't here because she's the one who really knows. Anyway, she has established a equivalence between QPCR for E. coli and the E. coli culture methods. I don't know whether it took her a season. I'm sure she had usable data after a season, but it's just really a matter of having sufficient data with which to compare. And I don't really know what the numbers of samples are, but I'd say something on the order of 80 to 100 samples would be get you started, depending on the level of statistical rigor that you wish to apply. Anyone else have anything to say about that, maybe with experience in this area? Rich?
Go through your website.
Yes, yeah, all you got to do is look at the TSD and it's in there. It's not a complicated statistical approach, but it does have suggestions on the minimum amount of data that would be required.
So the advantage that Julie Kinselman had is that she was doing a few beaches in Racine, Wisconsin. Here's where all of us in this room are just jumping right off the cliff. We're going to do all of our beaches, whether it's on a Great Lakes, whether it's in Saginaw Bay, whether it's in Grand Traverse Bay, whether it's in Lake Lansing, a tiny little inland lake or a river. So here we go. We know that if you have algae, it's going to interfere a little bit with the signal. You'll get an amplified signal. So some of our beaches are going to have a little bit more cladophora, maybe a little bit more stuff in them, a little bit more complicated matrix. Some of them are going to have very nice water samples, not much stuff floating in there. That's all going to make a big impact. And so that's where this might be a decision that's going to be, if we only need 80 to 100 samples, I don't think we got enough this summer. Some labs may have collected enough samples. But I think what we're taking our time because I know you have more to do than just monitor beaches during your day. Yeah, so what we're going to do is use this fall to look at as much data that you've collected, get a feel for are you guys getting what you want to see, and then we're going to start looking at all of the beach data. But we also want to convene like a work group, and this is where we will pull in your lab staff, like Amy and Ben Southwell and Chris and everybody. Pull you guys together, start looking at your data, and making those comparisons. Now, fortunately, is Tammy Sivvy here yet? Okay, she'll be here this afternoon with Rich talking about this. So Dr. Tammy Sivvy from Saginaw Valley State University has been doing those correlations back and forth for the beaches that she's been monitoring. So that we're going to take those little baby steps, and this is where each one of your labs may have to do that. You may have to do those little baby step comparisons for each beach, and then I'll be working with Erin, and we are going to call on Julie Kinselman. We're going to put some money in a grant to start getting her help on this, because Julie's been doing this for over 7 years, and she's very good at this. She's been helping others. So we're going to ask her to help us do this on a statewide basis. And we're monitoring over 400 beaches. So rather than doing 2 or 3 or 10, we're doing 400. And it's a diverse group. So I'd love to tell you that next summer you can use these numbers, but I think what you need to do is keep your health officer engaged in this conversation, so all of a sudden you just don't throw some numbers on his desk one day or her desk and you say, hey, here you go. And they're like, what's that mean? Is this good or bad? So, yes, Christine.
Yeah, and we're already doing that because we had that 2-year cancer survey grant, we can look at these and kind of predict what the results are going to be to a degree.
Yeah.
It's a little different now with water levels going up and different parameters, but politically, we want numbers.
Yes.
Because in court, that's what's going to hold up.
Right.
So, we have a council, but so yeah, keep doing. Everybody's doing what they're doing. I love what everybody's doing, and I'd love to at least in the next year to 24 months to say, okay, look, we can have results same day. We know what they are, and we can stay here.
Right. So for the webinar audience, the two things were keep using your sanitary surveys to make sense of your numbers, whether they're from CoAlert or QPCR, and then be ready for the political changes that you're going to be giving them new information. Donna Lee, you want to come up and make a comment? So Donna Lee from Wisconsin.
My only claim is secondary knowledge from conversations with people like Julie. What things that we're talking about is how do you best use the tools. And when I talk to Julie about her day-to-day decision-making, it's not all or none with the QPCR. She uses the sanitary survey information. She uses the QPCR results. She has models. She goes through and does that. So she will, sometimes she'll get a result by QPCR that she just doesn't believe. And she'll go back to the sanitary survey and the other information that she has based on the models and say, this is the more reliable information. So there's a certain amount of weight of evidence, professional judgment. And I think as we explore this, we need to look at when is it really critical that you have that number? What do you do when the number just doesn't make any sense? You're going to have some fallback procedures. And so being prepared for that is pretty reasonable.
Great point. And I think we had a question.
And Shannon, you know, we did all the filter and freeze this summer, and I have all my QPCR results, but I'd say 80% of mine are like 10 or less.
Mm-hmm.
So you still want me to run all those samples through just to see, make sure that they're coming out
right? Because
we don't have a lot of dirty beaches. I guess it's
yay,
but not real helpful when we're trying to.
Right. So the situation is this. Fortunately, in Michigan, most of our beaches, the E. coli results are less than 10. So some of our new labs, they've been filtering and freezing samples, and they already know, so we kind of already know with the QPCR results where they're very low. So now we're going to go ahead and start running QPCR on all these very low E. coli samples. And this is where I probably call on Tiong and Rich to kind of make a comment about that. At some point, we need to run QPCR on those low samples to get background levels. But then how much background levels do you need before you know, because all of us are working with very limited funding, and you don't want to spend $10,000 on a bunch of zeros, because you're like, oh, I got that already. So the most exciting samples are going to be the ones where the QPCR went through the roof, and you're like, ooh, I can't wait to run the QPCR on that. So I don't know. Does anybody have an idea of how much background levels do you need to make it? Do we have any idea? I mean, if not, this is a great question, and we can go back and figure it out. Right.
Yeah.
All right, so some of the feedback right now is that this could be a site-specific situation. But I think as everybody's just starting, it might not hurt to keep running those samples, because you kind of think of it as practice, that you know what the results are going to be. So if your QPCR results come back flying through the roof, you're like, oh, something's wrong. But we'll work on that, because that's a really good point. And I don't know the answer. We could ask Julie. We miss you, Julie. I hope you're listening. Any other points on the webinar?
We had somebody asking, how are people training staff to use QPCR? How did labs get certified?
Oh. All right, so the question was, how are we training labs to use QPCR?
No, how are people training staff? I'm sorry, how are people training staff? Sorry, I'm trying to read these over the internet. How are people training staff to use QPCR? How do labs get certified?
Right. You want to explain it, or you want me to with the class? Hopefully you guys aren't tired of listening to me yet. All right, so in our quality assurance project plans, we have set it up in a stepwise process for all the new labs. We don't have certification. We're living by a QAP, which, sorry, that's the way the word is. So we use the QAPs to go through this stepwise process. First, we want your lab to be able to run a standard curve that makes sense. Once you get a standard curve and your staff are running the standard curves and everything's beautiful and you're like, yes, we got this. Now you're going to get the E. coli spike samples from MSU or EPA. So then you start running those samples to see, can you run now E. coli and get a result? So then you get your results, you're going to call MSU, and you're going to tell them, this is what I got. What, is this making any sense? Did I get in the right ballpark? And that's also what qubit is for, right? Qubit helps you measure the DNA.
Yeah.
Right. So do you guys know what a qubit is? Similar to nanodrop? Okay. Once you get through that, we're going to let you go. You're going to start monitoring. Because you've already proven and you have confidence in your standard curves make sense. You've got a spike sample from MSU and you've got results that made sense. So now we got to believe that you can keep running. But there are some things you can do in the lab to make sure that you still gain that confidence. And that's, you want to explain like how you keep running the positives and negatives in each run?
I think for the standard curve, I mean, if you have a new staff running the QPCR, so you may have to rerun the standard curve. Like for example, you can run the standard curve for this season, and then if you are happy with that standard curve, and then you can use that. So I would advise that maybe for the next season, you can rerun the standard curve again to make sure that you meet the criteria of the standard curve. And I think some of the lab already received some of our spike samples. I think the Grand Valley State. And yeah, so if you're ready for that sample, just let me know and I can ship it to your lab.
And just one more thing to point out about the training, we do offer TIAS services for visiting your lab and helping you through the training process and running through a couple of the techniques. If you are not close to MSU, we have partners, some of those experienced labs across the state, like Tammy and Ben. So if you're up on the UP, we can connect you with an experienced lab, so you don't always have to try to connect with East Lansing. We're trying to get a whole network of support for you across the state. Other questions? This is like my undergraduate science.
We have a training video.
Yes, oh, and on our website, and again, we will put together a list of links for all of this information that we've been referencing throughout our discussion, but we do have a training video. So you can watch a trained technician go through the method. And there are a couple of them out there. So we have one that was created at MSU, and we have links to others as well. So our MSU video is actually the enterotoxy method, but we have links to those other videos so you can get a little refresher and watch someone run QPCR samples.
But we get the initial stocks of like the salmon DNA or the calibrators from Tian, and then we dilute them down to make working stocks so we're not doing this free stuff. But how do we take into account that we've diluted it down? Is there a way we have to trim the numbers when we do our calculations? Is this something that comes with noon, or is it when you started with a certain thing, you just kind of run through it? You know? When you dilute down to the working stocks, you have to then make some kind of calculation that you diluted it down in your final calculation.
I don't really understand your question.
So like we got the salmon DNA.
Yes.
And they say you can take like so many mils of that, put it in so many mils of QPCR water, so that's a working stock, so you just use that on a daily basis. But that's a diluted amount. So when you go to do your calculations later on.
Right, and I'm going to have Rich come up, and he might address this afternoon, but I'll let him comment.
Yeah, in the EPA methods, you don't have to take into account the dilutions because your calibrators are diluted the same way.
Okay, those are kind of your
Yeah, right. Okay. So, yeah, there's some. I think I made we made a point in the method C that salmon DNA can actually be pretty tricky to reproducibly dilute there. I don't know if it's because it's the source that we get it from. It's hard to get a homogeneous suspension of it. So you want to basically make up a working batch of that that's going to cover you for the whole study or the whole summer or whatever. But that's just a little tip that we learned from our experiences. So, I mean, you think we should be pretty simple, like, 10 milliliters to the liter or something like that. But especially the salmon DNA can be notorious for having troubles reproducibly diluting it. But if you're working with the same stock, it's always good. So just a little tip.
Thank you. Any other questions? If there are none, I would just ask our experienced QPCR folks to stand back up one last time so people can recognize you for the rest of the conference. So this is, again, we want to create this network of support for all of those working on QPCR. So on your feet, please. You can wave to people. Yes. So these are the folks to track down and talk to if you have questions that come up once we finish, because I hear that lunch is ready and we are ready to wrap things up. Oh, yes, and I was going to have our back table introduce yourself, or at least say where you're from so people can track you down. Chris Otto from Sleeping Bear Dunes. Great. So we have a group from Lake Superior State working with Ben Southwell, if I heard correctly. And as I mentioned, he is one of our expert labs. So for those of you who are new and are looking for someone to connect with, he has agreed to help. So a good resource for you. Thank you. And I'll turn it over to Shannon.
Thank you, Erin. Thank you, Tian. So thank you, everybody, for getting through this, stepping up into QPCR world. So now what we're going to do is we're going to take a break. And so I'm going to give some instructions for us in the room and also for the webinar. So for the webinar people, this is going to end this link. And so if you want to join us in the afternoon, you need to find the next link and join on the new link for this afternoon, which is QPCR data crunching. That will be with Dr. Tammy Sivy and Rich Hogland. And then, so Rich is going to go through that training, and then we'll have some more questions and answers back and forth. So we're done with the webinar. We'll see those this afternoon. So for us in the room, lunch is ready. However, I did not register yet. I cannot eat until I register. You have to have a ticket for Wednesday's lunch. Because what happened is, I don't want to go into logistics, but some of you, oh, this is what it looks like. So this is Wednesday's lunch. It's a white ticket with a blue bottom, blue top, or there's a light blue on it. So you need to show, it's in your name tag, but you have to register to get your name tag, then you get your Wednesday lunch ticket. And that's because you registered for the whole thing, the whole conference. If you only came today, then you need to go get a lunch downstairs somewhere, or anywhere you want. And then we'll be back here in this room to start up. Now at 1 o'clock, there is a Great Lakes Beach Association meeting. And that's, you're all welcome to come and put in your 2 cents. Meredith Nevers from the USGS is our president. And we're going to have kind of just a catch-up meeting. Talk about where is the next beach conference going to be. We are having our next Great Lakes Beach Conference. Rumor has it somewhere in the Great Lakes. So we're still thinking about where that's going to land. So we'll talk some more about that this afternoon with the Great Lakes Beach Conference talk. And then we're going to have the 2 o'clock to 4 o'clock or later will be Rich Hogland. And we'll be talking about data crunching. So I don't think there's anything else to mention. Just thank you.
Yeah, so lunches are going to be downstairs in the registration area, and exhibitors, there's a lot of exhibitors there already too, and posters somewhere right
Okay.
there.
So if you didn't hear that, go to the registration table, that's where lunches are, and there's a bunch of exhibitors down there too. So thank you again, enjoy the view, you're welcome to come back up here and eat if you want. Great. Thank you, Jim, sorry to put you on the grill all morning.